Good morning, distinguished scholars, colleagues, students, and lovers of mathematics across the globe. I am Ogusawo Temiloluwa, and I'll be your host for this wonderful summit, the Excel in Math Summit. We are so delighted to have every one of you on board, and on behalf of the organizing committee, it is my great pleasure to welcome you to the Excel in Math Summit. And this summit is just a special gathering that has been organized to celebrate the International Mathematics. Also, I would like us to know that today's summit is not just a gathering, but it's a convergence of ideas, innovation, and inspiration. So I don't know whether you are a student, you are a researcher, or you are an educator. We are delighted and we are so happy to have you with us. And I promise you that it is going to be an amazing time. You would not regret registering for this program or for joining the call this morning. Once again, I welcome you all, and I'm Ogusawo Temiloluwa. Thank you. Okay, without further ado, we will begin the summit now. Just as we promised that we'll be starting by exactly 10 o'clock.
Network.
Okay, so once again, I welcome amazing summit. I welcome you to this amazing summit. It is such an honor to have you here. And like I said earlier, you are going to have yeah. So okay, so we'll be beginning our submit now with an opening and welcome address. And it is my pleasure to invite the co-host for this amazing submit in the person of Mr. Yusuf Soni. And he will be the one to officially welcome us to this remarkable event. But before he comes up, I would like to just read his profile. I would like to just take us through the biography of Mr. Yusuf Soni. Yusuf Sani is a passionate leader, entrepreneur, and advocate for the advancement of mathematics education among young people. He is the second son in a family of six and has consistently demonstrated a strong commitment to personal growth, leadership, and community impact. Yusuf holds a Nigeria Certificate in Education (NCE) in mathematics and physics, and later earned a Bachelor of Science (BSc) in mathematics, reflecting his deep interest in the mathematical sciences and education. Beyond academics, he is an entrepreneur with diverse professional interests and skills. He has obtained several professional certificates in areas such as leadership development, craftsmanship, security expertise, and ICT analysis. In addition, he is a skilled fashion designer, showcasing his creativity and versatility across different fields. Currently serving as the national president of the National Association of Mathematical Sciences Students of Nigeria, NAMSTN. You is dedicated to inspiring and empowering mathematics across the country. His vision is to positively influence and impact the younger generation studying mathematics, encouraging them to pursue excellence, innovation, and meaningful contribution to society through the power of mathematical thinking. So, ladies and gentlemen, please roll in your reaction as I welcome our national president, Mr. Yusuf Sani, to take us in the opening speech. You have the floor, sir, Mr. Yusuf Sani.
Thank you very much. Good morning. Good morning, everybody.
Good morning.
Good morning, sir.
It's quite an honor to be here this morning. I want to appreciate everybody that is currently online for this summit, and also we all know that success is really a solo endeavor, and I believe by fostering an environment for transparency and mutual support, we will achieve more than we could ever do being apart. The goal today is simple. We are going to be learning from each other so as to build something lasting together. I want us to relax and enjoy the panelists that are going to be educating us today on the topic, and jot down what they have to say, and we pray for a very successful deliberation here. They say mathematics is a language in which the universe is written. If that's true, then everyone in this room is learning to read every fabric of reality. I want to welcome you all this morning to this summit. I pray we have a very successful summit. Thank you very much, and God bless you.
Thank you, sir.
Thank you very much, Sir Yusuf Sani, for that warm and insightful welcome. We deeply appreciate you, sir, and we do not take your presence for granted. As we've heard our president say, we have a goal for this summit. We are not just gathered here for gathering sake, but then we are here to learn and to know what it means to be a 21st century mathematician. Once again, I welcome you all to this wonderful and amazing session. Thank you so much once again, Mr. Yusuf Sani. So now our next segment is the convenance charge, the vision for the 10,000 mind. As we know that every impactful initiative begins with a vision, and behind this summit is a leader who is deeply passionate about empowering thousands of young mathematical minds. It is my privilege to invite the convener of this summit, Mr. Abdulateef, for the welcome charge. But before he comes up, I'll be taking us through his amazing profile. So please let's listen well. Abdulateef Adedeji is a record-breaking mathematical thinker, visionary leader, and the pioneering founder of Excel in Math Africa, recognized as the flipped classroom expert. He is on a mission to revolutionize African pedagogy by bridging the gap between theoretical potential and global professional impact. A scholar of historic distinction, Abdulateef graduated from Tai Solarin University of Education with a first-class honors in mathematics education, achieving an unprecedented 4.91 CGPA. Today, as a researcher at the International Center for Applied Mathematical Modeling and Data Analytics, it focuses on educational data science and the mathematical modeling of learning dynamics. His commitment to impact extends into his leadership within the National Youth Service Corps, NYSC. He currently serves as the overall CDS president for Oye local government, coordinating over 200 corps members across 15 groups to drive community development. He further demonstrates his dedication to digital empowerment as the president of the DL for All, that's the Digital Literacy for All CDS group, leading initiatives to equip local business owners with vital technology skills. His research contributions include co-authoring the March 2025 study in engineering report, a semi-analytic hybrid approach for solving the Buckmaster equation, application of the Elzaki projected differential transform method, showcasing his expertise in advanced analytical methods. Driven by the 2026 International Day of Mathematics theme, Mathematics and Hope, Abdulateef has established a high-intensity mandate to impact 10,000 students and early career professionals. Through this summit, he is shifting the global talent pipeline, commissioning a new generation of strategic architects to move beyond the numbers and build the future they once imagined. It is my privilege to invite the convener of this summit, Mr. Abdulateef Adedeji, to share with us the vision during driving this initiative. So please let's roll in our reactions and our emojis as we invite the convener for this amazing summit. You have the floor, sir.
Okay, good morning, everybody. I'm so excited to be here. Thank you so much for joining the Excel in Maths Virtual Summit 2026. As I've been introduced, my name is Abdulateef Adedeji, the club classroom expert and the founder of the Excel in Maths Africa. I'm so excited to welcome you all. And then, to be very quick, the aim of organizing this summit is simply to bridge the gap between academic excellence and career success. As I've said over and over again, that success in this era has gone beyond I graduated with the first class, I graduated as the best graduating student. And this is coming from someone that graduated as the best graduating student. It's not just enough that you have academic excellence. You achieve academic excellence when you are in school or out of school. It's now more important than ever than mathematics students or mathematicians generally. We start with thinking our identity as mathematicians. We start taking mathematics serious. We are currently in the digital economy, and mathematics is actually the language and the tool and the system altogether that power the digital economy. Are you talking about AI, cryptography? Anything you're talking about is powered by mathematicians, by mathematics. And the people that are actually in charge of this system are mathematicians. But you only benefit from all these opportunities if you are rightly positioned for it. So most of us have been sold that lie of, oh, you study mathematics, you just have to end up in the classroom either as a teacher, as a nursery, primary, secondary school teacher, or even as a lecturer. No, it is beyond that. There are now a lot of opportunities that are available to us, and that is why we are putting this summit together. The 10,000, the number 10,000 is not just something we throw around like that just to get people to feel like, oh, this is something good. No, it is a mission. We are on a mission to make sure that at least before the end of this year, we impact, empower, and equip at least 10,000 mathematicians, not just across Nigeria, but across Africa, with the mindset, with the skill set, and the skill set that will enable them to thrive in this century. So I'm so excited to welcome you all to the Excellent Math Virtual Summit 2026, which is in commemoration of the International Day of Mathematics with the theme Mathematics and Hope. So I want you to know that mathematics is beyond the number. It is a tool that can inspire hope among us as individual, among the society, and in the global world generally. So I wish you a great learning experience. Please engage with the speakers. Make sure you are here all through. Invite all your friends. This is not a summit you can afford to miss. Don't come with just your head alone. Come with your pen and paper. Make sure you jot things down. Okay, make sure you jot things down and make sure you stay to the end. Thank you so much and have a fantastic learning experience.
Thank you very much, Mr. Abdulateef Adedeji, for that inspiring charge. Your vision for cultivating 10,000 mathematical minds is both ambitious and deeply motivating. We truly appreciate your commitment to building a thriving mathematical community. I believe we can all agree that if for Mr. Lateef's initiative, we all would not be gathered here today to learn something as important as being a 21st century mathematician. Once again, thank you so much, our convener, sir. Thank you so much for the powerful initiative. We are enjoying the summit already. It is still getting started. We are still going into the main. So now, our next segment is the keynote address. As we know that the theme for today's summit is beyond the 21st century mathematicians. Okay, sorry, beyond the numbers. Beyond the numbers. That's the theme for our summit today. So now we'll be going into the next segment. That's the keynote address titled Beyond the Numbers, the New Rules of Success. Beyond the Numbers, the New Rules of Success. This this amazing session is going to challenge us to rethink what success looks like in the world of mathematics and beyond. I want to believe that many of us, when we heard that the theme is beyond the numbers, we might have been thinking that, oh, what does it mean to be beyond the numbers? But then we have an amazing keynote session that will help us understand this better. So to take us in this amazing keynote session is an amazing speaker in person of Professor Emmanuel Afolabi Bakari. In person of Professor Emmanuel Afolabi Bakari. So I'll be reading his profile as we proceed. Professor Emmanuel Afolabi Bakari is a distinguished full professor of applied mathematical modeling and data analytics at the Federal University Oye Ekiti, that's FOYE, as the director and founder of the International Center for Applied Mathematical Modeling and Data Analytics. He leads critical research within the West African Mathematical Modeling Capacity Development Network. His academic journey, degrees from LAUTECH and the University of Ibadan, supplemented by international research at the National Institute of Technology, India, and Mahidol University, Thailand. A prolific researcher, Professor Bakare has held prestigious postdoctoral and visiting scientist positions at the Swiss Tropical and Public Health Institute and the Abdus Salam International Center for Theoretical Physics in Italy. His work, often funded by the Bill and Melinda Gates Foundation and the London Mathematical Society, focuses on infectious diseases modeling, optimal control, and climate variability. He is a member of numerous global professional bodies, including the Society for Mathematical Biology and the London Mathematical Society, underscoring his influence in the global mathematical community. Ladies and gentlemen, great mathematicians, please join me in welcoming Professor Emmanuel Afolabi Bakare, who will be delivering a keynote address on the theme Beyond the Numbers, the New Rules of Success. Professor, sir, the stage is yours.
Yeah, thank you very much. Good morning, everyone, and welcome to 2026 International Mathematics Day, Pi Day. It's a pleasure. Okay, so it's a pleasure for me to be speaking here this morning. I want to really appreciate Abdul Latif for organizing this program. And I also want to appreciate every one of us for coming. Now, we are today celebrating the Mathematics Day, the Pi Day, which comes up on every 14th of March every year. So the 3 there represent March, and the 14 there represent the day. So it's 3.14. So the 3.14 is equal to pi. Now we are happy that we are here, and we can see a lot of things are going on in terms of mathematics all over the world. Now, going from artificial intelligence to machine learning and data science and everything. So you robotics and all that. So you find out that maths cannot be pushed aside. Now, once you remove maths from all of these things, everything is going to scatter. So we understand that. So this morning I'll be talking about the new rules of success for mathematicians in the 21st century. Now we know that we are in a knowledge economy. Now in the knowledge economy, what is going to thrive is going to be beyond the natural resources. So we are looking at resources from the point of view of knowledge, capacity building. And this capacity building, there's a lot of role that mathematics is already playing, especially in the area of navigating the aspects that has to do with the AI, the big data, and the interdisciplinary innovation. So there is a need for everybody to be carried along in this process. Now, so as a mathematician, now what are the new rules of success that we need to begin to travel on, going on from now, especially in the 21st century, to be able to be current, so that we can be current with the tides of things, and then we will also be able to know what is going on in the world and to also flow along and be relevant, or else we will be left behind. And then, mathematics has gone beyond writing stuff on the board, writing why the eggs, and solving and smiling and getting some solution, even through numerical schemes and all that. Maths has gone beyond that. So we are in an era where people are using math. That math you are putting on the board, they are using it to solve problems, real life problems. So the first thing I want to talk about is the challenging landscape. The challenging landscape. Now, there's a paradigm shift, and that mathematics is no longer just a support discipline. We find out that in many schools, they see mathematics as something not to even be a department, to build a department for, or to spend money on starting such a program. And then they just make it a supportive program, like a general studies, GST. They count mathematics as GST. That's something like an unavoidable evil. So, but we'll find out that math has gone beyond that. There are some universities currently now that they don't have a math department because they don't really know the importance of maths. And there are some that has mathematics department, like University of Medical Science in Ondo Town. You find out that their math students are very few. People are not subscribing for maths, especially because the fees are also high, and they feel that parents feel that well, if I take my child to go and study math, what will he become? My next door neighbor that studied mathematics ended up as a classroom teacher, and he could not even afford to buy a bike. After several years, he has been a teacher. So we find that people are not encouraged to do mathematics, and it's not because of anything, it's because of the ignorance. What that people don't know the importance of mathematics, especially in our current generation. So it is the primary, so it has gone beyond being a support discipline. It is the primary engine of the global economy. So when you talk about AI, you talk about cryptography, you talk about logistics. So the strength and the foundation of all of this is in maths. So it's a primary engine of the global economy. So you cannot, once you remove maths from AI, from cryptography, from logistics, everything is gone because it's a decision tool. So you find out that a lot of things are going on with the use of math in our days. Yesterday I was looking at a lecture on mathematics, essential mathematics for machine learning, and you find a lot of mathematics we are doing that we don't know their importance, going from calculus to probability to optimization and all of that, to even matrices, tensor, vector, and all of that we learn, but we don't know their importance, especially in the AI. So the AI integration, now automation handles routine computation now. Automation handles routine computation. So mathematicians now focus on creative formulation and ethical oversight, because we are in a period that, because of the use of AI, there are certain things you can do with AI now that even if you are waiting for human to do, you wait for a long time. But in a GV, you can do a lot of things with AI. So there is the AI integration, and it's telling us that automation handles outline computation. Mathematicians now focus on creative formulation. That is, we can develop models from the scratch, and ethical oversight. Now, the key trend in 2026 is demand for mathematicians in AI-related roles is growing at 34% annually. Demand for mathematicians in AI-related roles is growing at 34% annually. So if you're a mathematician, you must begin to think beyond the box. You must begin to think beyond the box, so that you begin to see how you can be relevant with all the equations, with all the methods, with all the theories. We need to start thinking, how do we get relevant, especially in the time or the season of artificial intelligence. Related roles is growing at 34% every year. So I also want us to look at the need now. What's the rule? The first rule is that we must master the why, not just the how. We must master the why. We master the why. That means the reason, not just the how of things, the why of things. Why? Because automation of routine. Machines can solve equations and run simulation faster than human. So if you want to do anything, just go to some of these AI tools like Gemini or ChatGPT and all of that. Then you get your things done within a few times. It can do all those equations. It can solve equations, big equations, and can even run simulation and will give you the code. So what is the situation? What is going to happen to mathematicians? The human edge is here. Success comes from understanding the intuition behind the models. So mathematicians are going to come with their own intuition, being able to have intuition and intuition behind the model. And that's why I tell people that now for AI tools to be useful to you, like ChatGPT and all of that, you need to have the domain knowledge. So success as a mathematician will come from being able to understand the intuition behind any model that's been developed. And then we'll be able to thrive on in the midst of what is going on around us. Now, the deep theory. Now, we need to focus on original theory development. So we need to develop original theory. And then high-level problem formulation that AI cannot replicate. We must begin to think like that. So our success lies in our theory. Now, if you're a mathematician, your theory base is weak, you are not likely to thrive, especially in the days of AI. So we must focus on original theory development and then high-level problem formulation that cannot be replicated by AI. And then machines solve problems. Mathematicians decide which problems are worth solving. That's where we stand. Machines solve problems, but mathematicians make decisions which problems are worth solving. So you need intuition to be able to say something about the model, behind the intuition behind the model. So we need to understand the intuition behind the model. Now, rule 2, the second rule is that become a mathematical translator. Become a mathematical translator. The most successful mathematicians work at the intersection of biology, finance, climate science, sociology. So it's no longer math for maths. It's math for English, math for biology, math for epidemiology, math for ecology, math for finance, math for actuarial science, math for physics, math for something else. So the problem now is that, the challenge now is that being able to navigate into systems, systems, different kind of systems, biological systems, social systems, to be able to see how can maths answer some of the questions that they cannot really do experiment to answer. Experiment may not be answer some questions. So mathematician will be there to answer those questions using mathematical tools. Maths to education, yes, math for education. So those applicable areas we must begin to explore. You must explain complex math speak in plain English to stakeholders and CEOs. Now, in being able to flow in those applicable areas, being a mathematical translator, you have to be able to understand the knowledge base. That means the domain knowledge in biology. Let's take for instance, or in education. You have to have a domain knowledge. So if you are using math, you are using math to explore the educational system with an understanding of that educational system. We need to understand. If you don't understand that system, your math will not be relevant. So we must be able to come in that direction. Now, so if you cannot explain your model's impact on a business or community, its mathematical beauty is commercially irrelevant. Yes. So if you cannot explain your model's impact on a business or community, its mathematical beauty is commercially irrelevant. So we must be able to confront our mathematics with other aspects of discipline in our community, in our society. We see a lot of problems that mathematics can solve, and that's where we can come in and being able to explain the model's impacts on a particular business or community is what actually makes the beauty of mathematics to come out, and at the end of the day, it becomes a commercially relevant subject. Now, number 3 is adopt AI native habits. We need to adopt AI native habits. How do we go about that? Use AI to find patterns in massive data set that a human eye would miss. Use AI to find patterns in massive data set that a human eye will miss. So that means we need to go into augmented analytics, where we use AI to find patterns in massive data sets. When you're having like 50 million data sets that a human eye will miss. So you begin to use AI to explore the visualization, the patterns in the data, and all of that. And then a new frontier, building models that can explain why they made a specific decision. So we need to build explainable AI that help us to build models that can explain why they made a specific decision. Now, we also need to go into learning to use large language models to generate boilerplate code, allowing us to focus on the core topic. So, like prompt engineering, we need to go into that. Learn something, new things alongside with your theoretical maths. Rule 4, technical stack for 2026. Now, some of us who are mathematicians, those of us who are mathematicians, we need to look at this. Technical stack for 2026. So we need to get the foundation, the three major foundation, especially to explore this coming generation, this new generation. Now, the first one is linear algebra. The language of matrices, vectors, and tensors. They are essential for AI. Language of matrices, vectors, and tensors. So those ones we are wasting in our various classes as a mathematician. They are very useful for people who are engaged in AI. And then understanding how models learn, the use of calculus and optimization. So where we have gradient descent. And then we also have the aspect of probability and statistics, where we manage uncertainty in real-world data. So you find out that those three aspects, probability and statistics, linear algebra, and then calculus and optimization, they are very important aspects in this current trend that we are seeing in AI and logistics and optimization. Now, the rule here also shows us that we need proficiency in certain software or languages like R, Python, and specialized platforms like Learn, LEARN, for formal proof verification. So we need to learn skills, get skills, not just the degree. Having a BSc Maths degree is not enough. You need skills. Then rule 5, cultivate mathematical resilience. Cultivate mathematical resilience. In 2026, a degree is a starting point, not a finishing line. Having a BSc, MSc, PhD, they are just starting point, they are not finishing line. So AI models hallucinate. Mathematicians must be the ultimate fact checkers. So you cannot be a mathematician that's a fact checker if you don't have domain knowledge. There are times that we type something on AI tools like ChatGPT, and it's giving us a wrong answer because of the hallucination. So we are the one to do the check. Ultimate fact checkers. Ethical awareness. Understand the bias in algorithms. Success now requires a moral compass as much as a calculator. So we must go beyond, just the basis. I type a particular thing inside there. I ask AI to find something, and then is bringing something out that is not relevant. Then we need to check. We need to look at that and check what are we going to do with that. Now, where are the jobs? Where are the jobs? Auditing algorithm for fairness. We have AI ethicist. You are a mathematician. You can be an AI ethicist. And then you can also be a quantitative analyst, real-time risk modeling in finance. You can be a quantitative analyst that is using modeling in finance, risk-time modeling in finance and actuarial science. And then you can also be a biomathematician. There are various aspects of biomathematics, about five of them. We have mathematical epidemiology, mathematical ecology, bioinformatics, computational biology. So you can find yourself in any of this area, and this area is very useful in the public health space, predicting the next pandemic or personalized medicine. And then climate modeler, simulating net zero transition paths. So there are a lot of things you can do with mathematics in the 21st century. In conclusion, the 21st century formula, I want to give you a formula for that success. Rigorous theory plus coding fluency, rigorous theory plus coding fluency, you bracket the two, bracket open, rigorous theory plus coding fluency multiplied by emotional intelligence. That's the rule of the success. The success in the 21st century for mathematicians is that they must engage with rigorous theory. You must learn the theory, mathematical theory, plus the coding fluency, like R or Python, and then bracket close, times emotional intelligence. Now you must be thoughtful, you must be curious, and never stop learning. You keep learning because there is an update every day. Update goes on every day. You keep learning. The future belongs to those who use maths to make the world more human, not just more automated. Thank you very much. I want to end here. I don't know if there are questions. Thank you.
Wow, wow, wow. That was an amazing keynote session. That was an amazing keynote session. Thank you so much. Thank you so much, Professor Emmanuel Afolabi Bakare, for that powerful and enlightening keynote. And okay, I would like to say that for me, what stood out from this amazing keynote session is the route to success in the 21st century, where he told us that rigorous theory plus emotional intelligence multiplied by rigorous theory plus coding fluency multiplied by emotional intelligence. So please let us try to hold that well. Let us hold that well. So I don't know if we have questions. So please, if you have questions, kindly signify by a show of hands, and I will call you to speak. But before we take on our questions, I'll be calling on our convener to say something little to us.
Okay, thank you so much, Temilua. Thank you so much, bro. Thank you so much. This is so amazing. I'm so glad and I'm so grateful that you're able to find time to actually do this. But not just to find time, but to share from your words of knowledge and experience with us. And I'm sure that everybody can agree with me that based on what you have learned today, what I've heard from Prof, you should never be a poor mathematician, number one, and you should not be an unsuccessful mathematician. You have just been equipped with the news of success in mathematics. So what else do you need? And guess what? The summit just getting started. So I just want to say one or two things about Prof. So I got to meet Prof in August 2024. That's like 1 month after my graduation, after my signing out of school, where I studied mathematics education. And it was so amazing seeing someone. He was the first person I saw that talked about mathematics in such a way that I felt like, wow. So my mathematics actually goes beyond just finding X and looking for Y. And that was actually what spurred me into like, oh yeah, let's how do I get started? And fortunately, so someone that is very accommodating. Currently, if you were here when my profile is being read, one of the things that was mentioned is that I'm currently a researcher and also a core member. I'm actually serving at the International Center for Applied Mathematical Modeling and Data Analytics. And Professor Bakar is actually director, and he's our father. He's someone that's always ready to share his knowledge, always ready to empower the next generation of mathematicians. So please, before you start asking your question, I want you to please let me to give him a virtual clap. Like, please let me to appreciate him. Thank you so much for God bless you, sir. Thank you for all you do. Thank you for being a source of inspiration. Thank you for being like the father that we need in the mathematics space in this era. Thank you, sir. So you can go ahead with the question. You can just be able to take one question if we have. If you don't have, then you might have to go to the next session. Thank you.
Thank you so much, Mr. Latif. Thank you so much, sir. Once again, thank you so much, Professor Emmanuel Bakare, for that amazing keynote session. Okay, I want to believe that it is not possible that we add that amazing session and then we'll not have questions. So please, if you have questions, kindly signify by a show of hands. Questions. Do any one of us have questions before we proceed to the next session? Any question? Okay, since there's no question, we'll be moving on to our next session. Yeah, just like our convener said, this summit is just getting started. We just finished our keynote session on Beyond the Numbers, the new rules of success, and we learned an amazing rule of success. As well, we also learned the job opportunities that are available for a mathematician in the 21st century. So since we don't have questions, we'll be moving on to the next session. Okay, so we now proceed to our special session titled The Mathematician's Privilege. Okay, so we now proceed to our next session titled The Mathematician's Privilege, unveiling the beauty, power, and global frontiers of the field. I repeat, The Mathematician's Privilege, unveiling the beauty, power, and global frontiers of the field. This session is going to explore some unique opportunities that are available to mathematicians in today's rapidly evolving landscape. And to take us in this amazing session is Queen Dr. Aminat Ige Lawal. So before she comes up, I'll be reading her profile. So please, let's follow through. Dr. Aminat Olawumi Ige is a multi-talented mathematician, researcher, and community leader who embodies the 21st century academic. A graduate of Lagos State University, LASU, and the University of Lagos, UNILAG, she holds BSc, MSc, and PhD degrees in mathematics. Our academic prowess was globally recognized when she emerged as the winner of the overall Best PhD Thesis Award at UNILAG for the 2022-2023 session. An achievement featured on international platforms like the South African Broadcasting Corporation. Currently serving as the Education Secretary of the Ali Moshood Local Government Education Authority, Dr. Ige is also a lecturer at LASU, that's the Lagos State University, and has served as the Assistant Director of Alumni Relations. She is a member of the prestigious Edinburgh Laureate Forum and has a versatile professional background, including past experience as a senior banking officer and data squad member at Sterling Bank. A dedicated girl child advocate, she organizes the YOA YOA mathematics competition to reduce subject phobia and encourage STEM careers. Our leadership extends to grassroots learners and the chieftaincy title holder, a prominent political stakeholder, and the Queen Mother of Isheri or Olofin Kingdom in Alimosho local government. Balancing her roles as a researcher and entrepreneur, she remains committed to replicating her success through the brave art mentoring of. Ladies and gentlemen, please join me as I welcome the amazing Queen Dr. Aminat Igelawal. We are so honored to have you with us, ma. You have the floor, ma.
Oh, okay. So can you hear me, Timmy?
Yes, sir.
Hello, Timmy, can you hear me?
Yes, sir. I can hear you, sir.
Oh, okay. So I'm so sorry. I'm just getting to know now that our speaker is not available at the moment due to some unforeseen circumstances. So what we're going to do is that we're going to go to the next agenda, which is to play the spoken word for the our International Day of Mathematics. So everybody just please stay connected, and then we're going to take it the way it's supposed to go. After she's only going to be able to join by I think around 12. So but then we're going to go on with the other session. So just give me a minute. I'm going to share the video now. So please
Okay.
stay here. Don't go anywhere.
Okay, so as we've heard for our convener, at this point, we'll be taking a short 5 minutes break. But please, let's not leave the call as we have an amazing video to play to celebrate the International Day of Mathematics. So please let us wait, sit back, and enjoy the video. Thank you so much.
They say mathematics is just numbers, just formulas, just symbols on a board, just something to pass and move on from. But nobody talks about what it really demands. Nobody calls it discipline. Nobody calls it resilience. Nobody calls it the quiet decision to attempt the question again after getting it wrong the first time. Especially here, where light fails, where resources are scarce, where doubt is louder than encouragement. And yet, we still calculate, we still attempt the proof. Because beyond the numbers, there is something bigger, something stronger than fear, something that says, keep going. We solve not just for X, we solve for ourselves, for our future, for the Africa that believes in numbers and people. They have never studied during a power outage. They have never watched a student hold a candle in one hand and a calculator in the other. In this part of the world, darkness is not a metaphor. It is 7 p.m. without electricity. It is a generator coughing outside the window. It is reading integration while mosquito debates your concentration. Mathematics for us is not just numbers. It is a lantern. A small, stubborn lantern refusing to go out. When the light fails, we derive. When the noise grows loud, we integrate. Because hope is not loud where we come from. Hope is quiet. Hope is a student writing an assignment after failing it twice. Hope is let X be, When X looks like hunger, like tuition, like uncertainty, every equation begins with the unknown, so does every African dream. The unknown is not the enemy, it is the beginning. We approach limits, not to stop, but to see how far we can go without breaking. We integrate broken pieces into meaning. We transform expressions into possibility. And pi does not end. Not because it is confused, but because it is infinite. And maybe that is us. Unfinished, unfolding, expanding. In a continent where systems sometimes fail, mathematics trains minds that do not. It trains us to see patterns in broken economies, to model flaws before they destroy homes, to create solutions that do not need foreign permission. This is not about 3.14. This is about persistence. Because every time you solve an equation despite the odds, you are proving something greater. That structure can rise from chaos. That logic can outlive limitation. The same mind that can solve for X can solve for impact. When you feel overwhelmed, remember, limits exist. When you feel small, remember, exponents exist. When you feel stuck, remember, transformation exists. When you feel like stopping, remember pi. It keeps going. And in a place where stopping would be easy, we keep going too. Mathematics and hope are not separate subjects. They are twin flames. One sharpens the mind, the other strengthens the will. Beyond the numbers, we are becoming. We are rising, and that becoming is hope. Happy Pi Day.
Wow, wow, wow. That was an amazing spoken word session. Okay, so if you enjoyed that session as much as I did, can you roll in your emojis? Just send in an emoji, a love emoji, a clapping emoji. If you know you enjoyed that session as much as I did. Thank you so much, Miss Abby. Okay, so before we proceed to the next segment, I would like us to just go into the comment section. At least we've spent almost an hour in this summit. So I would like you to just go into the group chat and just type something little that you've learned during this summit, during the past 1 hour. For me, during the spoken word, I learned that we are not solving just for X, but we are solving for the future. That we are solving not just for X, but we are solving for the future. And I am very sure that every one of us, we've learned one or two things. So please, let's drop them in the group chat so that others can learn. Thank you so much. Thank you so much. Oh, great. Thank you so much to all those who have dropped something. Okay, so I can see I learned that we must know. Okay, so I can see I learned that we must know the why, but not just the how. Yes, I learned that we must know the why, but not just the how. I learned that to succeed as a mathematician in the 21st century, I must be thoughtful, keep learning and curious. Wow, that's nice. Okay, from the spoken word, I learned that mathematics and O are not separate. Nice, nice. If you can solve an equation despite the odds, you can also solve a problem for impact. Wow, that's amazing. We are more than three on this in this meeting, so I don't know why I'm seeing just three replies. So please let's drop what we've learned. Let's drop what we've learned in the comment section. Thank you so much.
They say mathematics is just numbers, just formulas, just symbols on a board, just something to pass and move on from. But nobody talks about what it really demands. Nobody calls it discipline. Nobody calls it resilience. Nobody calls it the quiet decision to attempt the question again after getting it wrong the first time. Especially here, where light fails, where resources are scarce, where doubt is louder than encouragement. And yet, we still calculate, we still attempt the proof. Because beyond the numbers, there is something bigger, something stronger than fear, something that says, keep going. We solve not just for X, we solve for ourselves, for our future, for the Africa that believes in numbers and people. They have never studied during a power outage. They have never watched a student hold a candle in one hand and a calculator in the other. In this part of the world, darkness is not a metaphor. It is 7 p.m. without electricity. It is a generator coughing outside the window. It is reading integration while mosquito debates your concentration. Mathematics for us is not just numbers. It is a lantern. A small, stubborn lantern refusing to go out. When the light fails, we derive. When the noise grows loud, we integrate. Because hope is not loud where we come from. Hope is quiet. Hope is a student writing an assignment after failing it twice. Hope is let X be when X looks like hunger, like tuition, like uncertainty. Every equation begins with the unknown, so does every African dream. The unknown is not the enemy, it is the beginning. We approach limits, not to stop, but to see how far we can go without breaking. We integrate broken pieces into meaning. We transform expressions into possibility. And pi does not end. Not because it is confused, but because it is infinite. And maybe that is us. Unfinished, unfolding, expanding. In a continent where systems sometimes fail, mathematics trains minds that do not. It trains us to see patterns in broken economies, to model flaws before they destroy homes, to create solutions that do not need foreign permission. This is not about 3.14. This is about persistence. Because every time you solve an equation, despite the odds, you're proving something greater. That structure can rise from chaos. That logic can outlive limitation. The same mind that can solve for X can solve for impact. When you feel overwhelmed, remember, limits exist. When you feel small, remember, exponents exist. When you feel stuck, remember, transformation exists. When you feel like stopping, remember pi. It keeps going. And in a place where stopping would be easy, we keep going too. Mathematics and hope are not separate subjects. They are twin flames. One sharpens the mind, the other strengthens the will. Beyond the numbers, we are becoming. We are rising, and that becoming is hope. Happy Pi Day.
Nice, nice. Okay, I can see that most of us are now writing. I can see that most of us are now putting down what we've learned. So I'll be reading some of what I can see here out. Okay, so I can see that. Okay, someone asked how he can get the video. So the video will be sent to the participants group after the summit. So you can always rewatch the video, replay, and relearn and learn more from the video. Thank you so much. Yes, I can see that I learned that mathematics is beyond the numbers, formulas, and solving for x and y. Yes, correct. See that mathematics is the science of hope. With mathematics, our world can be impacted more meaningfully, thus confirming our hope for a brighter world and future. Wow, this is a great one, Mr. K. I can see mathematics is not just about solving for X alone, but it's about solving for our future. Yes. I learned never to be a poor mathematician. Yes, so mathematics is beyond a number. It's solving real life problem. Mathematics is about solving a real life problem with applications. Yes. What I learned is we solve not for X. What I learned is we solve for X not for ourselves but from the future. From spoken words, I learned that the same mind can solve for X. Okay, from the spoken word, I learned that the same mind that can solve for X can solve for impact. What I learned is that when you feel small, remember exponents exist. Mathematics trains the mind. I learned that I should master the why, not for the how. Mathematics is a tool that enhances our sight beyond what we see. Mathematics is a tool that enhance what we have, what we see beyond what we have. That's nice. Thank you so much. Thank you so much, everyone, for engaging. Yeah, so we'll be returning back to the summit. We'll be returning. Okay, I learned that mathematics help shape the world to be a better place. Oh, great. Okay. So like I said earlier, okay, so we're proceeding to a special session, and the title of this special session is The Mathematician's Privilege, Unveiling the Beauty, Power, and Global Frontiers of the Field. The Mathematician's Privilege, Unveiling the Beauty, Power, and Global Frontiers of the Field. And to take us in this special session is Queen Dr. Aminat Igelawal. Queen Dr. Aminat Igelawal. So before she comes up, I'll be reading through her profile. So please let's follow through. Dr. Aminat Olawumi Ige is a multi-talented mathematician, researcher, and community leader who embodies the 21st century academic. She a graduate of Lagos State University, LASU, and the University of Lagos, UNILAG. She holds BSc, MSc, and PhD degrees in mathematics. Her academic prowess was globally recognized when she emerged as the winner of the overall Best PhD Thesis Award at UNILAG for the 2022-2023 session, an achievement featured on international platforms like the South African Broadcasting Corporation. Currently serving as the Education Secretary of the Ali Mosh Local Government Authority, Dr. Ige is also a lawyer at LASU and has served as the Assistant Doctor of Alumni Relations. She is a member of the prestigious Edinburgh Laureate Forum and has a versatile professional background, including past experience as a senior banking officer and data squad member at Sterling Bank. Dedicated child, she organizes the YOA mathematics competition to reduce subject phobia and encourage STEM careers. Her leadership extends to grassroots governance as a chieftaincy title holder, a prominent political stakeholder, and the Queen Mother of Isheri Olofin Kingdom in Ali Mosho local government. Balancing her roles as a researcher and sociopreneur, she remains committed to replicating her success through the Brave Heart Mentoring Hub. With a virtual clap, please join me in welcoming Queen Dr. Aminat Ige Lawal. We are so honored to have you with us, Ma. You have the floor now, Ma.
Thank you very much, Temiloluwa. And I'm not sure my video is up yet. Let me see if it is. No, I don't know if you can see me. I can't see my own chat head. I can see my chat head. I can't see my own. But if you can see me, I think that's fine. And yeah, I'm also waiting for the host. Okay, thank you. I don't know why whenever I'm in a Zoom, I want to be sure I can't. Well, I don't know, but you can hear my voice. Maybe the host should just confirm that. Okay, I think yes, I can see that now. Yes. Thank you very much once again.
We can hear your voice, ma.
Yes, and now you can see my face too, because I can see it now. All right, so good morning, everyone. Happy International Pride Day. First, I need to apologize for coming in a bit late. And I want to give kudos to the organizers of the summit, so Abdulateef Adedeji and others. I almost thought down because of my busy schedule, but well, the mathematician's privilege is that even at the last call, the mathematician will always file in. So I'm happy to be here to be talking to young minds and old minds alike. I'm not so old, but let's say old minds alike anyway. And I love the theme of the summit, beyond the numbers. And that is why, okay, I think my slide is not on full screen by the host. Okay, so I use that as my footnote, because each time I tell people I'm a mathematician and I get this, oh, wow, oh, number. There are many times I tell people, see, when they say, oh, so you can do 3 times 6 raised to the power 2 raised to the power 4 raised to the power 100 times, and you can get the answer in 1 minute. I used to tell them that even someone who has never studied sciences could actually develop that ability. That is arithmetic. That mathematics is deeper. Mathematics go far beyond that. Mathematics is life. Mathematics is everything you can think about. You can find mathematics in everything, every field. You just talk about anything. So someone would say, what about the devil? If you go into the story in the Bible, then you will know that there's mathematics in what ensued between the devil and even Jesus Christ. So you can find mathematics everywhere. So I've been given the topic. I think I have 30 minutes. So I would do well to do within that period or less. The mathematician's privilege, unveiling the beauty, power, and global frontiers of the mathematical field. Once again, thank you for having me. Today, I listened to the moderator introduce me, and she started with Queen, Dr. whatever. On my slide, you can see that I wrote Aminat Olawumi Ige, PhD. Because yes, that's the highest academic qualification one can have. And a lot of people put doctor behind their names now. Your PhD should say, oh, I have a PhD. It's actually different from every other doctorate any other person might be holding out there. But when she said on the Queen, this, that, it tells you something. My experience, my exposure. So sometimes people ask me, how should I write my name? What's title? So you'll find my name in some places and you'll find the title honorable behind it. Some will write honorable, some will write chief, some will write queen, some will write doctor, different titles. And all these titles still belong to one person, a mathematician. And I must tell you, there are more titles coming, hand, not honorary. And it is only a mathematician that can pull all that easily. Or I also used to have a mathematical mind. So we have a lot of mathematicians who are still whiling away in other fields, but that are actually mathematicians and will rediscover themselves later. So sometimes you find people say, oh, I thought you're even talking like a mathematician, or So I would. It's divine. It's actually beyond numbers. It's beyond. If you ask me to do 10 raised to the power 3 plus 2 raised to the power 4 plus whatever, now I will tell you, please punch your calculator. We have machines already. I'm not a calculator. Mathematics is deeper than numbers. Please, you can start my slide now. More than numbers. I used to say mathematics is a teacher. It's a subject, it's a teacher, it's a trainer, it's a mini God. Mini God, I mean now. Because maths is one tool, I don't want to even call it a subject, that trains your mind to think logically. To discover the truth. So let me tell you something about discovering the truth. I don't know if you have actually tested your own capability. Hardly would you get away with a lie with a mathematician. Hardly. Unless that person is just playing away with maths. Hardly. The moment you tell a mathematician a lie, he or she already discovers that something is wrong. Maybe the mathematician knows the truth at that point or not, but he or she knows that there is an element of lie somewhere. Falsehood is in whatever the person has shown out. The mathematician will only take time to gather enough evidences, to gather enough facts, to be able to prove points. So when we solve mathematics, you know that, let's talk about numerical analysis, for example, even though it's not my field. You continue iterating. I remember the days we used to iterate with pen, not now that you use computers. So 13th, 14th, 15th, 16th. We know that once there is divergence at some point, we know that there's an error somewhere, but you don't know where the error is. So in those days, to discover where the error is, you have to go back to n equals to 1 and start tracing all over. Today, technology has made it easier. But you already know that there's a problem. So about 30 minutes into this meeting, so I want to confess now, the mathematician shall not lie. I told the organizer initially that I will need a slide and I don't have time right now. It's a very busy period for me. But then I told myself, how do I structure my delivery without a slide? So I think about 30 minutes into the time I was supposed to speak, I quickly brought up my system, LaTeX, and whatever slide you have now is imperfect. I don't know what you're going to score the slide over 10. I'll probably score it a 2. But for me, it just gives me the structure to what I want to say. And why did I go into that? When you type on LaTeX and it doesn't run, there's an error somewhere. Sometimes LaTeX just give you all those grammars. LaTeX will tell you line 1.00011. If you go to that line, you will look at it and you're not even seeing error there. But LaTeX has already said there's an error. You yourself know there must be an error before LaTeX. LaTeX knows where the error is. You don't know it, but you accept. Because LaTeX is a mathematical mind trained for that. So it is very, I actually recommend mathematicians, if the CIA needs people, we need people who should do undercover. In audit, when I was in the bank, I worked in the audit arm. I worked in several arms of the bank anyway. But especially in the audit arm, I easily find where the problem is, where the money is hidden, where the facts are hidden, because the mathematical mind in me does that easily. So math trains you to think logically, to discover truth. Before I proceed, I know Kausar is in this meeting. Kausar, please, if at any point, if they can't hear me or there's a challenge, please dial my number or Abdulatif, because I know Zoom can be fun and I may not discover. So it trains you to think logically, discover truths. And that's the last one, to see patterns and solve problems. By the time you sink yourself into mathematics, this happens to me every time. Even as I'm sitting before you, I'm facing a wall, I have fan, I have things around me. You'll be thinking, what if this fan goes up and another thing comes to the middle? What does it form? You would not look away. You would see everything you see will open up your mind to something that you are yet to see, but that you think that you know could be. You will see patterns, you will solve problems. If you're a mathematician and you're a police officer, the moment the suspect starts talking, in fact, you know our sinusoidal wave, the moment you realize that there are disconnects somewhere, you already know the possibility at the end of the whole interrogation. You see patterns, you solve problems. And when I say problems, I'm not talking about your mathematical problems, theorems and whatever equations. No. Even in the family, there's a way your brain is already expanded. You know how you suffer a lot before you prove theorems? And then let's say your analysis lecturer is telling you, you cannot give me the same proof. If you use epsilon equals to 0.25, the next person cannot use epsilon equals to 0.25. And the person does, the choice of delta will be different. Something will be different along the line, yet you are going to be solving the same problem. So mathematicians solve problems differently. Please move my slide. Hosts. Okay, I think I can move it from here. Okay, the privilege of a mathematical mind. So from my previous slide, I'm breaking this down here. Logical reasoning. When 10 people are in a room, the person that is likely to be what we sometimes call the devil's advocate, the person that is likely to think in a different manner, sometimes we'll tell that person, you are going off track. You see, off track might be an insult to somebody else. Off track is praiseworthy for a mathematician. When people say you are going off track, you are talking out of context. That tells me that you have a mathematical mind. You don't follow the crowd. But something as it should be at the base of its logic. Does it flow? It's not that it is disrupted. So the privilege of you being a mathematician is that when people are thinking in diverse manners, when someone is thinking north, south, west, east, if a mathematician picks north, a mathematician follows truth and pulls through. And even if your result is going to be different from that of every other person, it's going to make sense at the end of the day. I've mentioned pattern recognition before. So we realize we know how let me make this a bit funny. If you are a female, or let's say either a guy or a lady in a relationship, if a mathematician falls for the same gimmick over and over again, it's because that mathematician has fallen for the weakness of his or her mathematical mind. You are now trailing a pattern. So a mathematician is likely to make, now get this now, a mathematician is likely to make the wrong choice twice. Because when you recognize pattern, there's another thing that should be done. You should be able to decipher if it's a wrong one or it's a right one. But mathematicians are stubborn in mind. So most times we want to go further. You feel it's wrong, but we want to take 2 more steps. Even while solving, you want to take 2 or 3 more steps to see if, let me say, okay, that's when you will now say, then definitely, because you've done it once, twice, the 3rd time, the 4th time, that is when you now accept as mathematician that, okay, this is a pattern and this is probably the wrong pathway. For any other human, the first mistake or the first thing, they may just say, oh, this is wrong, and move away. But let me tell you the beauty of it. For a mathematician, you never can tell. Probably on the third or the fourth, realize that there's a pattern, but it's not actually that wrong pattern. And you would have missed the part if you had dumped it at the first point. So there is something that mathematics does to your mind, analytical thinking. And if you have ever been told that you are an overthinker as a mathematician or you are a perfectionist, take it as an accolade. If you don't overthink, there is no way you will stand out as a mathematician. You have to overthink. And the thing is, it creeps into our normal day-to-day life. You think everything beyond what it presents physically. And the way we solve problems, the way your mathematical man solve problems is not how every other person solve problems. If there's a problem, let's talk about this Iran and US war right now. Every other person will say, let the president of Iran sit at a table with the president of US, or let US bomb them and hand them. They just give a straight answer. A mathematician will give you a structured solution. A mathematician will start thinking for Iran, can you move your schools from north to west? USA already knows that your schools are in the north. And if they bomb where you have kids, you become weak. A mathematician will take the problem step by step. At the end of the day, the solution is not something the mathematician dumps on you and then all solutions become wrong. No. If a mathematician highlights, solution path for you, 1, 2, 3, 4, 5, 6. What it means is that even if 6 fails, you still have step 5 to fall back on. A mathematician will not just give you a solution that you will run with, and if it fails, it is total failure. So, if you have ever been, should I say insulted, or somebody has ever belittled you for being a mathematician, and the person has told you, mathematics, is that what you are studying? Okay, no problem. Finish now and come and teach my children in secondary school. Please just laugh at that person. Because even if as of today, if the world has not realized who mathematicians are and the power that we build, though we have seen some level of realization, but they've not seen how powerful we are yet. They've not seen that power in its full elements. They might not have realized it yet, but they will eventually come to realize it. So don't lose your tempo because somebody is telling you, oh, mathematics. Because math naturally produces problem solvers for the world. Every problem you can think of in the world, mathematics is there to give the world people who will solve it. It is now left for the world to put them in those positions so that those problems can be solved. Please move the slide. Next, please. So let me talk about myself now, because when I got this invite, I know Abdulateef Adedeji knows how very busy I am at this moment, but I know he didn't invite me to come here to teach you Lebeg. He didn't invite me to come and teach you my functional analysis that I'm very popular for. He didn't invite me to come and tell you how you can move from graduate assistant to lecturer 1 to senior lecturer. No, that isn't it. He wants me to speak to what mathematics has done for me, my achievements. So I'm going to talk about my journey as a mathematician so that you can now realize your power as a mathematician. Lecturer, fine. We all know that the mathematician can be a teacher, you can, or a lecturer, whatever you call it. You teach mathematics. I've done that. I did that. I would have put it after banking, because as most people felt I came to academics after banking. No, I taught in a university and a polytechnic before I went into banking. I went into banking as a mathematician with MSc Mathematics. I attended Banking Academy and I came out the overall best. I've never done trial balance, cash book, whatever, all this financial performance management in my life. But I went into Banking Academy and I trumped everyone that has been doing that all their lives. Why? How? Someone would say it is with the grace of God. Yes, God is ultimate for every one of us. But the mathematics in me helped me. You see, during my Banking Academy days, I was doing other things. I shouldn't be living back in academy. I was doing other things and I was still coming to class. Sometimes I record. And you know this thing that people used to do in secondary school, somebody pulls that stunt on me. So a few days to the final exams, no, few weeks to the final exams, somebody took away all my reading and writing materials. And I was stuck. But what still helped me? I am a mathematician, don't forget. I am different. I am unique from any other person. So I took few photocopies that I could still grab from people. I did my jottings. I burnt the candle because I already have the zeal. I have the strength. I have the resilience. You know what mathematics does to you? You prove a theorem 2, 3, 4 days, and you don't even get the answer. You don't know, and you continue. It builds resilience. And that is why a depressed mathematician is a mathematician that has not wielded his or her power. When I say depressed, you can, of course, breathe through depression. At some point, some of you know my story, but you always get out in good time because that is how those equations and theorems get you depressed. But you know you have to get a solution, and then you jump on it and you keep moving again. Today, I'm a public speaker. I've spoken on 12 stages. And sometimes I prepare 1 or 2 days or a few hours, and I still go there and deliver, and people see hail me and still clap, and I'm like, oh God, what if I have prepared for 2, 3 weeks? But because I'm a mathematician, I know I have structured problem-solving skill. So I know how to break my speech. I know how to break into the structures. I know what they want to hear. I know when to say it. I know when to stop. Which people actually, other people say have to go to, to attend seminars to train, for trainers to train them how to break down structure, how to do this, how to do that. A mathematician has that skill naturally. I write poems, I write articles, I'm on editorial boards, I am a politician. And I remember people saying, oh, politics is not for people in the classrooms or whatever. Then politics is for who? If you are a natural problem solver, because you're a mathematician, and you say politics is not for you, and you are complaining about the problems in our countries that are not getting solution, then you are one of our problems. So if you have that passion for politics, I'm saying to you today, mathematics will only make you a better and a successful politician. Today, thank you, Abdulatif. Today, I am also a community leader. So when people bring problems, you remember I said the mathematicians know how to discover the truth. So when people bring their rifts and you have to mediate, please move to the next slide. As a mathematician, you already discovered the truth. You just have to find a way to siphon the facts from them. Math strengthens leadership. Strategic decision is because you have to, in fact, you want to prove your theorem, you have to be strategic. Systems thinking, problem solving, I've talked about this before. So beyond those theorems, beyond those lemmas, beyond the equations, beyond the graphs, beyond the iterations, mathematics is something that already places you as a natural leader, and it is left for you to explore it. Today, I'm the Education Secretary of Ali Motion Local Government. It's a political appointment, but I am a mathematician, and I am now using mathematics to drive excellence in the LGA. Please, next, please. Beyond academia, mathematics prepares you for so many things. I only put 4 here. If you're an entrepreneur as a mathematician, you will rarely lose. Rarely, I said rarely. You will rarely suffer a loss as an entrepreneur. Yes, you would probably be a medium risk taker. We are not very high risk takers, but you rarely lose. Mathematics in technology, I've talked about that before. In governance, I've used myself as an example. In finance, in fact, when I got the banking job, I became really deepened in banking processes. I told my MD, you need more mathematicians, and they employed more mathematicians. At least I can mention 1, 2, 3, because finance is not successful without mathematics fully embedded in it. Next, please. Next, please. So math does not limit you to the classroom. Math does not limit you to writing articles that you will still be begging some people to review and edit and review and then send back, and they tell you it's H1 index, it's H2 index. Math is a foundation for everything you may ever dream of that you want to become in life. Math has supported my own roles in community influence, in public leadership, and in traditional responsibilities. It sharpens your clarity. Mathematics makes you extraordinarily wise. You become a sage once you are very good at mathematics. Next, please. You become a sage. And if I've had people say, where do you get this wisdom from? From God and mathematics. Always say it to them. At the global frontiers, if you want to model climate, in fact, let me even leave climate. During COVID-19, we have a lot of mathematicians that wrote articles because they have to use predictive models to let the world know what is going to happen in the future. I said there's a mini God element in mathematics, data science, AI, financial technology, every innovation you can think of. In fact, I'm looking at a bottle of liquid soap in front of me now. And I remember the first time I tried to make it, I didn't get it right. Why? I did not mix in the right proportions for some. For some, I think the numbers were written. I actually put the number 3 chemical before the number 2 chemical. And that is sequence. So math sits at the heart of every innovation. Next, please. Next, please. The borderless mathematician. So you know now that you don't need to be everywhere in the world. It's for you to be a renowned mathematician. You can work remotely. And for those of you that are still sitting 100% in the mathematical field, please make sure you have a LinkedIn account, connect with other mathematicians, have international collaborations. That is how you expand your exposure. Because here in Nigeria, we have limited resources. They are often ahead of us. But when you have partners there, they expose you. And before your other colleagues there who do not have partners abroad, before they catch in on the new trend, you already have it. And there's this advantage with you being the first movers of a particular discovery, of a particular innovation, of a particular solution, of a particular result. So when you work remotely, you'll be one of the people positioned to solve problems globally. Next, please. Math trains the most powerful tool in the mind, in the world. I said that before, your mind. Math reworks your mind. Before you studied mathematics and after you studied mathematics, go and examine how you reason. It is your extraordinary power. Mathematics is the extraordinary power you have as a human. Do not restrict it to what Dr. Adeleke has told you to solve, what Professor Lalere has told you to solve. Use it, expand it. Next, please. Expand it. Think boldly, explore widely. Forget about mathematics as a subject. Think of anything you think you want to achieve and you want to become in the world. Then use mathematics to achieve it. Next, please. Next, please. Mathematics may begin with numbers. So I call it the hen to high because it has worked for me and for so many. It may begin with numbers, truly. We may start with our numerics, but mathematics always ends with influence. If you model and you are able to solve a problem with your model, you would have influenced something in the world. As a politician, I have great influence because I am unique as a mathematician. And so I know how to do many things differently. So you may have started with numbers, you may be working with numbers now, but I want you to know that at the end of the day, you should be able to transform your knowledge, your numerical knowledge into influence in the world. Next, please. I think I have 5 minutes. So I have a blank slide. And this is another power of a mathematician. And I intentionally made this slide blank. I said occupy. Say the blank slide as the word, as the space. You can occupy any part of it as a mathematician. The best lawyer in the world, historically, was once a mathematician. I actually studied mathematics up to PhD level. So I have many things I still want to become in life that are not even related to science or to mathematics, but I'm going to do well with them with my mathematical mind, with my mathematical resilience, with my mathematical exposure, with my mathematical power. Go and occupy the world. Occupy any part of the world. Mathematics has trained you and is training you to be able to fit into any box. Occupy. Today I brought 14 slides because we are celebrating the International Day of Mathematics, 14th. Why did I think I should bring 14 slides? It is the mathematician in me. I started a slide and I think just said, today is 14th, you are celebrating, for them to also relate with the Pi Day, build nothing less or more than 14 slides. You can see pattern in what I have just talked about. Next, please. So I want to thank you. But before I go, I want to say something that I want to repeat something that I have said before. That mathematics is the foundation for you, for everything. It does not limit you. If anyone has ever talked down on you as a mathematician, take it as the charge, a charge to prove yourself and to do more. Because the world might not have realized who you are as a mathematician today. The world is coming to realize it very soon. So don't just sit back and say, oh, since I'm a mathematician, I have to teach, I have to, no. I have told you before that mathematics begins with numbers, but we are the heart of leadership, of innovation, of influence. So at the end of the day, you have to be one person who, wherever you get to, whatever you say, whatever you do, whoever you relate with, you are going to live high level of influence. Today, my own life is a proof that mathematics does not confine you. Mathematics expands you as a public servant, as a politician, as a royal mother, as a traditional title holder, as a former banker, as an award-winning banker, as an award-winning academician, as everything I have wanted to become and that I have still become. I am saying thank you. And this my thank you slide is first to mathematics for training me to be all this, and then to you for listening to me. Thank you and have a wonderful day. God bless you. Yes, please occupy Afolabi John. Thank you very much.
I choose to occupy.
Please occupy.
Thank
The
you
world is
so
your
much.
space as a mathematician. Thank you.
Thank you so much, Queen Dr. Aminat Igelawao, for that amazing session. To be honest, I enjoyed every bit of that amazing session. And I think I am saying the mind of every other person here. We really enjoyed the session. Thank you so much for sharing from your well of knowledge. Thank you so much, Ma. So I don't know if any one of us have questions for the trainer. Do we have any questions to ask her before she leaves? Do we have any question for her? Questions. Please, if you have questions, signify by a show of hands. Do any one of us have questions? Okay. I can see one. Oh, Mr. Latif. Oh, okay. Okay, over to you, sir.
Wow, this is so amazing. Thank you so much. Thank you so much. I don't take this for granted. Like this, we cannot know how happy I am that this session came to reality. Like, thank you so much, Dr. Ike. It's a great pleasure. I don't even know what to say because, as she said, I know how busy she is. Like, I know how busy she is, and it really means a lot that she's able to like find this time. In fact, when I saw this card, I was so surprised. Like, where did she find it? I just together. Okay, I'm glad that you do this. I'm sure, as you said, you're not invited here to come and teach us Lebego or anything. And to be honest, man, you did a fantastic job. The goal of this session, if you hear when the uh moderator was introducing this session, we call it a special session because it's meant to inspire, it's meant to motivate, it's meant to like show you that as a mathematician, it's a privilege for the world that you are a mathematician. We have always seen ourselves as just second class or second grade people.
Yeah.
But I'm sure that you have had today and you are here today from you know now in your spirit that as a mathematician, you are not just you are a blessing to the world. So please, I want you to go out there. Please let's appreciate Dr. Ide. Thank you so much, Ma.
Thank
Thank you.
you. Thank
I
you.
don't take this for granted. I really appreciate this.
You're
So I
welcome.
think one person is having question. We can't afford to hold down. Like she has a lot of places to be.
Don't
Please.
worry, I'll take questions.
Can you take
Don't
one
worry. Go
question,
ahead.
man? Oh,
Go
okay,
ahead,
man.
please.
So let's just take that one question. Similo, are you there? Please go on. You can take the question.
Okay, please, you can go on with your question. Please, if you have a question, kindly go on with the question. Thank you.
I don't think they have questions. I think they choose to occupy. Okay, there's a question. Okay, I've seen one.
Okay, Ma, please, how do one collaborate with others? Ma, please, how do one collaborate with others, especially internationally?
Okay, so I mentioned one before. I think I'll say more. So collaborate with people internationally. I'm going to break it down. So you mean you are in Nigeria? So how do I have someone in Turkey? How do I have someone in the US that I'm working with without traveling? First, I said, oh, have a LinkedIn page. Let your LinkedIn page read that you are a mathematician and you are open to international partnerships and collaborations. 2, put your work on your LinkedIn page. If you go to my LinkedIn page, in fact, I've not touched it in a while because I want to revamp. And you may not see a lot of mathematics on my LinkedIn page. So you should know your goal. I had a goal in mind, and I made sure my social media pages actually achieved that goal. That goal was not for mathematical collaborations, and I used it. So you want mathematical collaborations, let your page say that. Even on your Facebook page, put your articles. If you are working on something, you've not gotten it right, put it there that I am working on something. I'm open to people who are interested in similar field that we can work with. On Facebook, on LinkedIn, send requests to people who are in your similar field. Okay. You're on LinkedIn, you can search. I think on Facebook too, you can put keywords, you can put topology, you can put modeling. So once you put modeling, when you put artificial intelligence, it's going to bring out the profiles of people who have such keywords on their profiles too, and we link you to them. You send them requests. You can go into their DM. Be articulate. I am a young mathematician. I am this, I'm that. This is where I am. This is where I would like to be. I would like to, also work together. I would want you to introduce me to what is happening in your school, to the research you're currently on. This is what I'm working on. This is how I can, and you just form those clicks, you form those links. Now, Excel in maths, was created by Ablative now. Now, for people who will be in this clique, they would share ideas. So when you share ideas, even if you don't have somebody in Canada that you're working with, but there's someone in your team in Excel that has someone there, you team up, you start working together. That is how you build international collaborations. You attend conferences. So when you attend international conference, either here in Nigeria or in Ghana or in Benin Republic, you will find at least 1 or 2 international people, even if they are Nigerians, because I know they have grants to attend. Walk up to them, collaborate with them, tell them, open up your mind. You are a mathematician. A mathematician should be bold. I said it before, be bold. I say a mathematician I used to tell people that if I want to enter Aso Rock today and I set my mind to it, nobody will stop me at the entrance. A mathematician moves with courage and boldness. So you can't afford to be shy as a mathematician. Talk to people at conferences, and also contact people online, open up, and you get there. So the other person says, how do we train our mathematical mind? Moderator, I've taken charge. Don't worry, because I don't want to waste your time. How do we train our mathematical mind? The first thing is this: the fact that you're studying mathematics, it's already there. The mathematical mind is built. What you need to do is to activate it. How do you activate it? You activate it by first believe that there's a solution to every problem. First have that belief and believe that you can solve any problem. The first thing is to believe in yourself. Once you believe in yourself, then don't be docile. Don't be lazy about thinking, about reasoning. Don't give up easily. When you don't give up, the same way you don't give up because you want to pass your exams, because you want to be able to solve what professor, whatever, and doctor, whatever questions you've said. Don't be lazy about attempting to solve problems. There was a time we tied water in nylon, transparent polythene, light polythene nylons when I was young. They call it ice water. Somebody woke up one day and started sealing it, and everybody forgot about ice water. If that person was lazy about reasoning, about deep thinking, it won't come to be. Train your mathematical mind by first believing that you can solve any problem, then make attempts. No matter the number of times you fail, continue to make attempts. Continue to try. You see, there is no failure in the mathematics, in the mathematician's dictionary. For every research that gets stuck, you see where you stopped is actually a result. So don't be shy. Don't trash it. Don't keep it away. You can give it to somebody else. It might be where you got stuck. That's where somebody will pick it from. And that person will get a solution, a result. At the end of the day, one day, you will get the credit that this result was a build up upon the result of so at some point. So a mathematician does not fail. Just once you don't give up and you are determined, your mathematical mind will become activated and you will just follow through. So I think I've seen another question. How do we reduce? Oh, sorry, I think there's one before that. As a mathematician, can we have the mind of an entrepreneur? Yes. I said it before, yes. You can be anything with mathematics. Okay, what is entrepreneurship? You are talking about standing on your own, and then some people will later work under you. You want to build something that you're going to be driving on your own. You're a mathematician. You have the power of strategic thinking. And that is the most important thing for an entrepreneur. You have to think, you have to know how to think outside the box, how to present your products differently, how to convert clients or prospective customers to people who have actually paid your company. Yes, as a mathematician, you not that you can. You are a natural entrepreneur. You bet results every day. You bet results that you sell when you send it to those international journals. Okay, so you should be able. Okay, so Mr. Latif said we should take the last one. Okay, I will just read everything and give a general answer. So how can I, as a mathematician, help someone who came into mathematical field by chance and not by choice? By mentoring that person. Mentor the person, tell the person can, and always encourage the person to look for the part of mathematics that person can. The person doesn't have to be everywhere. Look for that field, that part of mathematics that the person can do well with. That person should take that into real life problems that the person would like to solve. How do we reduce anxiety and math phobia in mathematics? This is one whole topic. I think I will ask the coordinator to give you can come to my Facebook page and we'll discuss that. Okay, I think the last one is how can we excel in mathematics? For those of us that found ourselves by chance, okay, it's still the same. To excel in whatever you find yourself in by chance, first you have to learn to love that thing. If you block your mind that I will never know it, then you will never know it. But if you say, I think Latif can know it, I can know it, then you can. So one, do not have a closed mind. Two, talk to mathematicians that have excelled in that field to assist you. Thank you very much.
Wow.
Right,
Thank you so
much. Okay.
Okay, thank you so much, Ma. Thank you for the amazing session. Thank you for giving us answers to our questions. We are deeply grateful. We are deeply grateful. Thank you so much. Thank you so much, Ma. I believe we had a great time during the amazing session. Yeah, thank you so much, Ma. Okay, so we've just concluded a session, and after a session is another session. So now we're moving into another session, but this session is different from the others as this is an highly practical session. We saw in the group that we were asked to get a laptop, because we'll be doing something practical during this session. So now we are moving to a highly practical segment of our summit, the technical, and the theme for this session is the technical. Oh, okay, yeah, highly welcome, Ma. You're highly welcome, Ma. It's a technical workshop actually, and the theme is the modern arsenal, an introductory workshop on R for the 21st century mathematicians. As we know that in today's world, we need to have a knowledge on computational tools such as R. So we'll be having a facilitator to take us in this session. We'll have someone to take us in this session in person of Mr. Olasupo Idowu Isaac. Mr. Olasupo Idowu Isaac. So before he comes up, I'll be taking us through his profile. Okay, Idowu Isaac is a PhD. Idowu Isaac Olasupo is a PhD researcher in mathematics at the Federal University, Oye-Ekiti, Nigeria, and is affiliated with the International Center for Applied Mathematical Modeling and Data Analytics. His research lies in mathematical biology and infectious disease modeling, with a particular focus on understanding the transmission dynamics of malaria in Nigeria. His work integrates mechanistic epidemiological models, Bayesian inference, and time series analysis to investigate disease transmission patterns and assess the effectiveness on public health interventions. Olasupo holds both a BSc and a MSc in mathematics from the University of Ibadan, where his master's thesis examined the structural properties of ultra-distributions. He is currently a recipient of a PhD scholarship funded by the Bill and Melinda Gates Foundation during ICAMDA. His research has led to publications in journals including PLOS1, PMS infectious diseases, and modeling earth systems and environment. He is an active member of several scientific networks, including the Applied Malaria Modeling Network and the West African Mathematical Modeling Capacity Development, WAMCAD initiative. He has facilitated modeling workshops, presented his research at international conferences, and served as a guest speaker at various academic forums. Through data-driven approaches, his work aims to improve understanding of malaria dynamics and contributes to evidence-based public health decision making in Nigeria. So, ladies and gentlemen, please join me as I welcome on board Mr. Olasupo Idowu Isaac, who will be guiding us through the essentials of the R programming language. The floor is yours, sir.
All right, thank you so much for having me, and I want to say happy International Mathematics Day to everyone on this platform. It's a good thing that as mathematicians, we are coming together to celebrate this day, and young mathematicians for that matter. Please, I want you to confirm that you can hear me. Can you all hear me? Can you hear me?
Yes, we can hear you, sir.
Okay, that's good. Okay, so I'll be taking a workshop, an introductory workshop for that matter on R. But before I start, because you know, the theme you gave me says talking about arsenal that you need for 21st century mathematics. And you must have noticed that while my profile was being read, I finished from the University of Ibadan, and my first and second degrees were on pure mathematics. I love pure mathematics so much. But sometime in life, I decided to switch to applied math. Now, in this 21st century, generally, academics and the world had moved from theorizing to problem solving, theorizing, to problem solving. Usually, mathematician, why we ask a lot of questions is because things are not clear to us. The road is not clear. Everywhere is dark. So you are wondering, where am I going from here? What do I use my Lebesgue integral to do? What do I use my my Cauchy theorem? What do I use it to do? And all that you are taught in class is definition, theorem, corollary, and all of that. But like I said, the world has moved into what we call problem solving. And so that's why for now, I've seen that for you to be a problem solver as a mathematician, you need some tools to garner and beautify your mathematics. Somebody recently said, oh, mathematics is very cheap. It's not costly. You only need pen and paper. And I said, gone are those days. You need pen and paper. Today, you don't just need pen and paper. Yes, you need your pen, you need your paper, you need your computer, and you need knowledge of programming. You need computational tools. You also need statistical tools. If you are going to beautify your maths to solve problems out there, you need those tools to beautify your maths. And then before you know it, your math becomes something that can answer questions. And you can be surprised that I'm a mathematician, but I'm doing a PhD that is interested in answering questions around malaria in Nigeria. And by the mercy of God, this we are doing, relating directly within the National Malaria Elimination Program of the country, responding to their questions through the Federal Ministry of Health. And that tells you that as a mathematician, you can do so much. So, but when they say we can do so much, it's important for us to know how can you do so much. One of the hows is that you need to learn some tools, which for instance include R, and I'll be taking you through the use of R. Okay? So this is an introductory workshop on R. So I also know that the audience I'm dealing with, they are mathematicians. So young mathematicians, I have tailored this introductory workshop to be more of something math related. Of course, R can be used for several things like machine learning, data science, and all of that. But then we'll still talk about that maybe in a bit. But then I want to first come from what you are familiar with, from where you and I are familiar with. So I would just be going through this introduction, and then we go into hands-on. Introduction, because I need to whet your appetite a bit. I have requested that the facilitator, the host, Mr. Blackley, would tell you. I want to believe some of the participants here have installed that, because we are going to be doing hands-on session. So R is a very powerful environment for statistical computing and for mathematical modeling, and that also we use for data analysis. And in that, you're able to do data visualization. And you can also use it for what we call reproducible research. It helps actually to support a lot of simulation and statistical inference. Very strong for visualization capacity. I don't think I've seen any, I know of any software that has strong visualization capacity like R. Yes, I can tell you that. And then it's very large. It has very large ecosystem. We have, developers everywhere, R developers developing things every day, packages for usage, and it's open source. It's free. It's free for to use. Why do we need it as mathematician? We need it for numerical simulation, for statistical inference, optimization, differential equations, for time series modeling, and so. And then some of its application, we use it in mathematical biology, in epidemiology, financial mathematics, machine learning, and biostatistics, as I've said earlier. So how do we get to start with R? Sorry, somebody was requesting to get the software. You can I think I have. Okay, good. So I wouldn't want to take so much time on this because I've told you to install R. So I want to believe that has been covered already. But then I will switch now to R platform because when you open R, the interface you have there. Now, let me say to you as mathematicians, you have a very strong advantage. You know why? You know how to learn languages that are not English. Imagine now somebody comes to your class and you say that when is a function continuous, and you say, somebody writes on the board, you say, given epsilon greater than 0, there exists no data greater than 0, such that f of x minus f of x naught is less than epsilon whenever data minus data, whenever x minus x naught is less than data. Oh, wow. How do you get to understand that? And they are not writing that in English. They are writing all the Greek languages, and you're able to interpret it. So the same thing that you need for any particular software you want to learn, the language is very important. The syntax is very important. So once you know how to interpret the language, that's the first thing that. So now I will switch to my R platform. Sorry, let me take this guy away from here. Okay. I'm trying to remove. Okay, so if you have R on your laptop and R Studio, you have installed R and R Studio. So the R that you have installed there is the one that's like the engine that drives the body. So you cannot use R Studio without R. You can use R without using R Studio, but then R Studio is a user interface that makes it very makes it more user friendly. There are a lot of things there. So if you are there now, can you please open your R Studio by going to the icon? You see R. You see icon R. That is either on your desktop as you have installed. So click on it, and when you open it, so you will have something of this nature. Okay, I want to believe that I have people who are following me, doing what I am doing currently. Okay, so please open R, and when you open it, when you open your R, you have 4 pins. 4 pins. So look at, I'm not sure, can you see my cursor? Confirm you can see my cursor so that I can really. Can you see my cursor? Good.
Yes, sir.
So here is what we call the editor. Now, in case your own came like this, came like this. Let's say you have something like this. You are not seeing your editor. What happened is that the pane down here has been maximized. So come to this icon to minimize. When you minimize, it will just show your editor here. So you have your editor here, and that's where you type all your codes. Any code you type here, you can always edit it anytime. So this is your console. Console here, you see console here. So that's your console. That's anything you type in the editor, that is where it appears. It appears here, it's executed here, the code is executed here. However, you can type the code directly here too. You can type it directly here, but it's not something that is easily editable. So that's why. And then if you type in the console and you by chance close your laptop, all the codes you have typed, they are gone. So, but you can always retrieve it if you type directly into your editor. This pane is what we call the environment. Here, you soon see environment, history, connection, and story. When you type, for instance, R gets to save something in its memory. So this is where it appears, everything that you must have saved. I will demonstrate it as we go on anyway. And here you have file, plots, package, help, viewer, presentation. This pane, that's where your plots displays. You know, when you want to plot something, you will soon see as we go on. My time is really running. Now let me start with the first thing. So I say R as a scientific calculator. Now look at it. You can always do, so if you're on R already, just on your console, just type 2 plus 2. No, 2 plus 2 or plus 3, for instance. So when you type any code in R, for it to be executed, you must run it. Now you see here, see my cursor here, you see run. It says run the current line. Yes, so you can run the current line by clicking that, but me, I always prefer the shortcuts, because as you can see in front of it, you have Control plus Enter. So meaning that if I want to run any line, I can always use a Control plus Enter, and it will do the same thing as this one. So, and you don't have to come to the end of it. Anywhere on the line that the cursor is, it will run that line. So for instance, so me, I've typed it before, so I'll just run it. Let's say I put it here, I put Control Enter. Can you see now in my console? In my console, I have 2 plus 5. Now, 2 plus 3, I have, you have 5 there displayed. Now, but you also see something came with it. Now, in R, sometimes you want, as you are performing certain operation, because you are just learning. And if you are not just learning, the very best way of coding is that you must know how to put what is called comments. So I have put comments in order to help me. So when you put hash before you type anything, it becomes a comment. So, and R will not execute it as a line of code. It will just take it as a comment like that. So R can perform basic mathematical operation. You see, just return it like that. And then here I put addition. You just return it. It's not performing anything on it. But the one I didn't put hash on, where I put 2 plus 3, it has executed it. And that's what I'm interested in executing, which is 2 plus 3, 5. So again, I come to the next line. So you can be typing as I'm also doing my own. 10 over 4, you know, this is division. You use back a forward slash here to do your division. Again, Control Enter. You can see if you come to your console, you see your answer and then 2.5. Okay, so I want to do get square root, SQRT, and then again I run Enter. It gives me 4 in my console. This is natural logarithm. That is logarithm to base E. So you run that also. You see, you have your console. At your console here, you have your answer displaying. Exponential 2, for instance, it takes ESP, that's exponential. And then there are many, you can do many other arithmetics, you know, of your normal arithmetics, as you know, in mathematics. As many of them, your addition, your subtraction, your multiplication. Okay, say I want to do multiplication now. I just do 2 times. You see my times now, 2 times 3, 2 times 3, Control Enter. So you see in the console again, your answer coming out there. Okay, so good. I want to believe that all those other basic mathematics you can always you see, your answer comes out very fast. So R is very fast. Now, the next thing I want to do is talk about creating variables. As mathematician, you are familiar with what we say, let X be 5. Let Y be 10. So this is what we are doing. I'm assigning to X 5. We call it assignment. And this thing that I've just highlighted is called assignment operator. Assignment operator. So now I want you to see something very quickly. Once you do that, so what is it? It's just less than and minus in front of it. But the very short way, you can put alt on your computer and minus together. Once you do that, it gives you the assignment operator directly. Alt and minus. Alt and minus. So once you do that together, it gives you assignment operator. So I'm assigning X to 5. I'm saying the R memory should keep X to be 5 in its mind, and then 10. So if I run it now, you see, it didn't do anything in the console other than just return the same thing I put. But if you come to the environment here, you see now it has put something in there, x5. That said x is 5. I want to believe you can all see that x is 5. So if I run this also now, again, it has also added y to be 10. Now, let's say I want to add y now and x together, and I also want to assign it to another value. I'm calling it z, for instance. I'm saying z, keep z in your memory as 5 as x plus y. So by the time you do that, let's run it. Can you see now that in the memory again, that's kept z as 15? Now, even though you say you should keep it as x plus y, so whatever x plus y is, it has done the arithmetics already and kept it in memory like that. So I can decide to use it later on, just like I use x and y in what I've done. So, but then if you do that, you see it's only in the history that you saw that z is actually 15. But if I want to really see z, I can run this line also, z, that is, I'm calling it call z. So you see in your console, it has now brought z to be 15, as you can see here. Okay, so alternative assignment operator is to use equal to, but we discourage this a lot because sometimes when we are doing other operations, we make use of z, equal to also, particularly when you want to do logical operations, and equality also comes in, and sometimes it can be confusing. So for us not to confuse this most of the time, it's advisable that you use this assignment operator. All right, so yeah. And let me say to you here now that, for instance, I have assigned my s to be 5. One thing is that if you decide to use that same x to be something else, then r will overwrite the previous one. Let's say now I put x to be 12 now and run. Let me run. You see now that x used to be in the environment, global environment, it used to be 5 before, but it has now become 12 because it has overwritten what it had in its memory before. So in case you are intending to maybe put something else, so you don't use the same variable that you have assigned before. Vector, you are all familiar with vector. For instance, now you have heard of n tuple. You have heard of n tuple, the word n tuple before. Ordered pair, you have heard of ordered pair. For instance, now if I say what's an ordered pair, you know of your x and y axis. So where you have x comma y, all right. But so that's vector generally, right? But if it's of n tuple, you have x1, x2 up to xn. So you can always depict that in R also, and you use to bring the entries of an n tuple vector together. This one, if I am to talk about this now, so what's the dimension of this vector in terms of the number of entries now? 1, 2, 3, 4, 5. So this is 5 tuple. So and the entries are actually 1, 2, 3, 4, 5. So to take it, to combine the numbers together, we use this small c. R is sensitive, is case sensitive. So if you use capital C, it will throw error at you. And then you have this small c to combine is called concatenate. It's called concatenation. So once I do this now, again, you see now that R has now, if you look at the environment, now I have V. V now is a number that is saying it's 1 to 5, right? The length is 5. So here now it contains 1, 2, 3, 4, 5. But if I want to see it displayed, I can just again run this, and then it tells me the console here that my V is 1, 2, 3, 4, 5. So as a vector, I can perform different operations on it. For instance, I can say, if I say V plus 2, that means I'm going to be adding 2 to each of the components of each of the elements. I'll be adding 2 to. So if I say this now, you can see now that I have 3, 4, 5, 6, 7. So 2 has been added to each of the components. So if I say V raised power, so this is power. This cap is to, it's used for power. I do this now. It just simply takes the square of everything, each of the components, and then I can take sum of all the elements by using the function we call sum. So when you want to sum up things, you can use the function sum. So I take sum, and then it sums up all the elements in V. It tells me it's 15. I can take the mean, that is the average. So I just say mean of V, and then it gives me 3. So as you can see, we can do a lot of other things with that. So I've taken the mean like that. I can take the standard deviation of that V. I just take SD of V, right? And then it gives me this. I can take the variance of V. I just take, variance of V, and then, so I have 2.5. So I know somebody will say, so how am I going to know all these things? Keep on practicing with as you practice, you know it. Okay, so next thing is, as mathematician, I know that most of the time you want to create a matrix. You want to create matrix. Now I want to create a 2x2 matrix. In a 2x2 matrix, you already know that the entries there will be 4 in number. So if there will be 4 in number, it now depends on you. Do I want to arrange it by row? I mean, what I taught you earlier by this is a vector. So I'm going to the first thing that is needed, the most basic thing that is needed here. First is to declare your vector. And you know that if you know the number of rows you want to create and the number of columns you want to create, and it's a 2x2. I want a 2x2 matrix. If I want a 2x2, that means I must supply 4 elements, because it needs 4 elements to create that. So let me run this, and then I indicate it's sufficient to. Once I indicate the number of rows, it already by itself knows that the column should be 2 in number. So if I do this now, it has kept in its memory again a matrix, and then let me now see that matrix as I run it. You see, I have, so now you will see that the way it has arranged it now is that it has taken the first 2 elements here as the first column, as you can see, and has taken the second one as the second column, which is 3, 4. Now let's say I'm interested in not arranging the first 2 elements as the first column. I need, the first row. I'll just say by row, right? I'll just say by row equals to true. So if I don't use by row equals to true, by default, I will arrange the elements column-wise. But if I say by row equals to true, and I do this, look at this now. So you see that's reorganized it. So it has taken the first 2 rows, the first 2 elements to be the first. All right, so I've gotten a matrix, the first row, again, you will see that having set it to true now, it has already replaced what A used to be as what I had before as the first column being 1 and 2. It has replaced it because I have run A to be something else. So that's how you have to see that. So I move on to matrix operation. Yes. Now let's say that I have another matrix, B. This time around now, I'm not putting by row true. Yeah, so B, and I want to add A and B, just say A plus B, and it gives you. Don't forget our A, what our A was before. In matrix addition, you do components-wise addition. So 1 plus 1 here, which is this is our A, matrix A, and then this matrix A, matrix B. Okay, maybe I should call B. I can just highlight B so that I call it, and then you see. Okay, so this matrix B, and then this is matrix A. So matrix A. And you see that the addition now, can you see the first one, 2 plus 1, which is 3. Again, 1 plus 2, 3, and then 3 plus 0, 3. and then 3 plus 4, 7. So you see that. Then let's say you want to do multiplication, unlike when you are doing multiplication of numbers where you just put this star. Here you are going to be putting percentage, star percentage. That is matrix multiplication. So if I do A times B, of course, you know, if you want to multiply two matrices together, you know the rule that the column of the first term must be the same as the row of the second one. So if you don't do that, R will show you some error. Okay, so I have this now. A times B, you know, your matrix multiplication is just giving your matrix multiplication directly. Okay, I can do the addition again. So matrix A, this matrix A, matrix B, and then A plus B. So you see, A plus B is this. Why is A plus? You know, don't forget that I've written by row through. So for A, so I have matrix A plus B, and then A times B, giving me this. Of course, you can see I've taken jets. I'm running. And that's why I have to actually prepare my slide this way, because I know that this hands-on and I don't have all the time. Abdulateef has decided to give me 40 minutes for what he knows that we normally take days to do. So I'm taking jets. I'm running. I'm sorry, and maybe I will just share the quotes with you too for you to practice. It's just, like I said, an introductory thing. So I want to take transpose of A, for instance. If I take, so I just use T, small letter T, to take transpose of A. So A transpose. So don't forget what A was before originally. So let's compare what A was before. A was 1, 2, 3, 4. But now if I take that transpose, my row becomes column. So you see now that this is it. Then the other one too, this is it. So A transpose goes on like that. Then if I want to take the inverse of A, I just say solve A, solve A. If I do that, it gives me this. You know how to take one. In fact, 2 by 2 matrix is the easiest one to look at in terms of taking it inverse. It's just a matter of you taking the negative of this main diagonal and then multiplying everything by the determinants. You know what I mean, dividing by the determinants, and so in the end you are going to be having this as the inverse, and your determinant is actually -2. So it's -2. And so you are having this. All right. Now you can also get the eigenvalue of A, for instance. Let's say, now don't forget, now I'm assigning this eigenvalue an eigenvector now. I want to get eigenvalue and eigenvector. So I say eigen of A. Eigen of A. So eigen of A, it has saved it in its memory already. It tells me I have list of 2. That means there are 2 things contained in there. So if I want to assess what are those 2 things contained in there, I have eigen, and then I take $, and it immediately gives me, I have both values and vectors. So if I put values, which already I put before, so I don't need to write that again. So once I run that and it gives me the eigenvalues, so these are the eigenvalues. I want to get the eigenvectors also, so I get eigenvectors of that same matrix, and I have this. Okay, I want to believe people are following me. I want to believe you are enjoying the class. I know I'm running, but then that's why I decided to come from what you know, since you are mathematicians. Okay, so now you see, now also we can use R to write function. So I want to write a function that will be defined as x² plus 2x plus 1. How do I do that? Say I want to assign that function, I want to call it f. I'm assigning it as f. So what is f? F is defined as function of x. It's a function of x. F is a function of x. And then what do I want it, the function to be? I want it to be x² plus 2x plus 1. Even though I put this return, it's not all the time you have to put. You may not put it to still run. If I don't put it, it will still run. So, okay, so I put f as a function of x. So this word function is taking it to create a function here. So if I run it, it's kept in its memory again. You see here now, it's telling me that I already have a function. So in the environment, and then as soon as, and I want to get a f of 3, you know, you have, let's do it as mathematician. F of 3, what do we expect? x², 9, 2x, 6, 9 plus 6, 15, plus 1, 16. So let's get it then. F of 3 gives me 16. So it's beautiful. It just tells me that this is 16, and you can get any other thing. Say I want to get f of, yeah, good. I love that. F of minus 5, for instance. I just put minus 5. Why am I able to use f of? Because R has kept in its memory that I've assigned f to be something. For instance, let's say that it's not compulsory I use f, I can use any other thing. Let's say I use g, right? If I use g now, right, the same way it has created a g function for me here, I can say g of 3, the same thing will happen. If I say g of minus 5, the same thing will happen. So I don't have to stick to f or something. Okay, so I move on. Okay, you can also do numerical derivative. For instance, you know how to do derivative numerically, f of x plus h minus f of x minus h over 2h. It's just the same thing as if I say f of x minus f of h over x minus h, you remember? So either way. I want to, like, I'm defining derivative, the derivative of a number. So again, I'm taking that as function because it's taking function of x, h, and then the step, which is h. So f of x plus h minus f of x. So I'm defining this over 2 times h. So I run the function, and then it has kept again in its memory that I've defined a derivative. So if I now say, get me the derivative of f at 2. The derivative of f at 2, say 6. So which, if you do your calculation, to actually get the same thing. Okay. Then we have conditional statement, for instance. Look at it. Conditional statements, your if functions, if statements. Now here I'm assigning x to be 5, right? So now I want to know, is x positive? So I'm saying if x is positive, tell me positive, right? If it's positive, tell me positive. Is that okay? So look at it. It says positive because x is positive. Now let me change it. Let me change it to negative. If x is negative, right? Print positive. Now let's see what will happen because x is not negative. So you see now, I put x to be this, and it's not printing anything because it's not negative. So it's not printing anything. So, but let's say now that I put, there's something we call else. We call it if else statement. I can say if, right? This way, x is positive, is negative, I want it to print, let it print positive. Sorry, print negative. Okay, else. So I say else prints positive, right? Okay, positive, right? So I want to do something here. Okay. Okay. So else if s is positive. So print this. Okay. Oh, sorry. Yeah, I can see something is wrong there. Okay. Oh, all right. Okay, sorry. I'm getting something wrong here. Yes, if X is positive, okay, print. Okay. Okay. Okay, so let's see this. Okay, good. So I said if S, okay, if S is negative, print positive, right? Oh, else print negative. Now you see there's a confusion here now. S is not positive, right? S is positive, right? Our S is positive. Okay, so it should have been if S is positive, print positive, else print negative. Okay, so let's run this. Positive, right? Because S is positive. So S is positive. So if S, because S is positive that we have declared here, so if it's positive, print positive, else print negative. But because okay, let me put S minus 5 here. Let me run X. Okay, so and then run this now. So it's negative, right? Thank you. So those are that's a conditional statements. Now that then I have what is called loop. Now sometimes you want to perform some task repeatedly. For instance, now you want to take x squared of numbers from 1 to 5. It's the same thing. That's 1 square, 2 square, 3 square. What you are performing is a square of number. You are taking square of number, but you are doing that for different numbers. You are doing that for different numbers. So you don't need to start putting 1 square, 2 square. So you can just put this for, so we call this for loop. So it helps us to just take, so this I, it means that when I is, so when we say 1 to 5, that means 1 to 5 is 1, 2, 3, 4, 5. That's a sequence. So when I is in 1 to 5, print I squared. So if I do this now, it just gives me 1, 4, 9, 16, 25. Do we get? So it keeps on. Okay, so our time is really up now. I thought I'll be able to see some other things. Okay, let me just at least plot something for us here. I'll just plot a graph and then that will be all for us because obviously, like I told you, the time given to me is too short. Okay, I want to, for instance, I want to plot this graph before, I have sequence from 0 to 1, and this 0 to 1, I'm taking by the step is 0.1, that means 0, 0.1, 0.2, so I have it here. The X that I've been using before will no longer be the X again. So you can see now that when I run it, it's now 0, 0.1, 0.1, because it's a sequence. Then I take this sign of it, sign of X. So if I want to see Y also, I can see this. So I have Y also give me this. So I can plot, this is a very basic plot. How, like I told you, you can make your plots to look anyhow you want it to. It's a very basic plot. So once I do this now, you see, it gives me X and Y, X on the X-axis and Y on the Y-axis. I can decide to customize this map, this graph, any way I want it to look like. I can add any other beauty on it. Say, for instance, I want X to be of blue color, and I can do this. I plot it to be blue color. Let's say I want to also plot the one that is of sign, cos X together along the same. I just do this. I use lines, and then it gives me all that. So there's a lot to do with R, that I've, at least to start with, that I put, because there is really no time to do this. Maybe I believe that this will already steer your interest. There is a whole lot to do with R. This is just the very beginning. There is, I believe that this will launch into study R, and then materials. We have material called the Book of R, and we have several video materials that you can watch that can introduce you to R. And then from there, you can do so many other things: machine learning with R, data science with R, mathematical modeling with R. And that's what we are using, for instance, to answer a lot of questions. But this is to introduce you. So I want to say thank you for staying through, and I want to believe that you brought on onto this. Thank you. And over. So over to you.
All right, sir. Thank you so much, sir. Thank you so much for having the session. I'm so sorry. I know that we can't know enough. We have loved to cover more, but then these are, as we say, this is just an introductory workshop. So for those of you that are just hearing about art for the first time, I know that this is enough to actually ignite your interest for you to start doing more. And if you have no, if this is your first time learning about art, I can assure you this is a language that you need to know, especially as a mathematician. So please don't forget. So thank you so much, sir. Thank you so much. I don't take it for granted. I really appreciate your presence. I appreciate how much effort that goes into putting this together, being here with us. I know how busy your schedule is. Thank you so much. And please let me to appreciate him personally, especially my supervisor in my center, as really the one taking care of me here. So please let's appreciate Mr. Edo. But thank you so much, sir. I really appreciate. So we're going to be running. Temilolo, are you there? Because we have our time is fast spent already, we're just going to move straight to the next session, which is our panel session. So Temilolo, I can go on with the profile. Our panelists are ready, and they actually have, like, they've been here since the beginning of the session. So thank you. Yeah, please can take over.
So thank you so much, Mr. Olashukwu, for that amazing session. We deeply appreciate you, sir. Thank you so much. Okay, so we've now arrived at very important and exciting part of today's summit. We'll be going into the global panel session. And I believe that we know that when something is global, that is not from, okay, let's say not from our country, yes, global. So we have also, like Mr. Latif said, our panelists are ready for us. They are very much ready for us. And to lead us in this panel session, we are honored to have Dr. Dansu. Okay, we also have Dr. Adejimi Adeniji and Dr. Emmanuel Jesunyo Dansu. Yeah, and also we have and also we'll be having on board our convener, Mr. Abdulatif. So I'll be reading out the profile of our panelists now. Okay, so first I'll be starting with Dr. Adejimi Adeniji. Dr. Adejimi Adeniji is an applied mathematician and research leader whose work sits at the intersection of mathematics, public health, and societal transformation. He holds a PhD in applied mathematics, specializing in mathematical modeling of infectious diseases, epidemiology, and socio-economic systems. With over 8 years of experience in university teaching and research, Dr. Adeniji uses mathematical tools to address real-world challenges from disease transmission dynamics to migration patterns and workforce instability. His research integrates climate variables, socio-economic indicators, and artificial intelligence-driven modeling to provide data-informed recommendations for policymakers and public health interventions. He develops data-driven mathematical systems that transform complex societal and public health challenges into measurable, predictable models, helping decision makers move from uncertainty to evidence-based actions. Currently, his work focuses on climate socio-economic modeling of infectious diseases, integrating machine learning and advanced dynamical systems to improve outbreak prediction and intervention strategies. Dr. Adeniji is the founder of the Black in Mathematics Association, BMA, a global initiative advocating for greater representation, collaboration, and recognition of African mathematical researchers. He is also the founder of MAEPIMS, Mathematical Modeling, Epidemiology, Machine Learning, and Social Intelligence, an interdisciplinary initiative and research challenge that brings together scholars to solve pressing societal and public health problems using mathematical innovation. You're welcome, sir, Dr. Adejimi Adeniji. So I'll be reading the profile of our second panelist. That's Dr. Emmanuel Jesunyo Dansu. Dr. Emmanuel Jesunyo Dansu is an assistant professor of mathematical biology at Tohoku University, Japan, and a former MEX scholar who graduated as valedictorian of the Graduate School of Information Science at Tohoku University. His academic journey from earning a first-class Bachelor of Technology degree and a distinction of Master of Technology degree in Industrial Mathematics at the Federal University of Technology, Akure, Nigeria, to completing a fully funded PhD in Japan reflects a sustained record of excellence and global academic distinction. A recipient of multiple international grants and honors, including the prestigious Japanese government MEXT scholarship, Dr. Dansu is passionate about equipping students and early career professionals with the strategic insights needed to navigate global scholarship opportunities and build borderless academic and remote career pathways. Ladies and gentlemen, please join me as I welcome our panelists, Dr. Emmanuel Jesunyo Dansu, Dr. Adejimi Adeniji. So please, with a virtual clap, let's welcome them. And for the moderator of this amazing panel session, we'll be having our host, Mr. Adedeji Abdulatif. You're welcome, sir. You have the floor, sir.
Thank you so much for the introduction.
Good afternoon, sirs. Good afternoon, sirs. Thank you so
Good
much. Can
afternoon.
you hear me, sir?
Absolutely. Thank you very much,
Sure.
Abdulatif.
Okay. Good afternoon, sir. I don't know. I don't know if I should say good afternoon or good evening. To
Oh, John.
Dr. Jeffrey. I know it's evening. Like, thank you so much. Our speaker, as you said, today global panelists, like they are joining from different. Like, I think we are probably in three different continents right now. Yeah, three different continents, like having a session. So thank you so much for being here. They have joined since the beginning of the session, even though they have the lion last share, the last lion share. So thank you so much, sir, for being here. So the title of the panel session is the borderless mathematician. And then what we just want to do is that we want our mathematicians, especially here in Nigeria or Africa generally, to get exposed to the fact that as a mathematician, they are not limited. They're not just limited to the four walls of the classroom, and they're not limited to a particular location. That whatever they know and are learning in school is something that they can apply everywhere. But then before we go into the questions, I'm just going to be asking us one or two questions. But before we go into that, even though I know we have been introduced, I would just like you to please just give us a little bit of uh, introduction and just share a bit of your journey with us in 2 minutes. Like, yes, who is Dr. Jason? Let's start with this and how has it been so far? And also, I would like us to answer one simple question. Do we find ourselves are we a mathematician by choice or by chance? So, 2 minutes.
Okay, so I should go first, right?
Yes, sir.
Because my okay, let's not bring our how did you put two of us together in the first place?
Yes.
You want us to start our drama here, but it's okay. Right. Thank you so much, Abdul Latif, for this initiative. And I think it's a very great one because that is what I mean. I'm very excited. I have a YouTube channel, for instance, but I'm very excited each time I see another YouTuber from Nigeria teaching mathematics. In fact, I personally, anytime I see that, I subscribe and I promote it because we've benefited a lot from the West. We should also, it's time to give back. And when I see initiatives like this being pushed forward, I think it's a very noble one. So I wanted to keep at it and keep expanding, keep going. So to my story, I don't know, 2 minutes. Let me be sure I don't because I can talk till tomorrow. Yeah. Okay, 2 minutes. Now, I was born in Badagry in Lagos State, Nigeria. I attended local authority primary school. I'm emphasizing some words. So I attended local authority primary school, Ajara Badagry in Lagos State, Nigeria. Then I went to Badagry Grammar School, Lagos State, Nigeria. And when I was leaving Badagry Grammar School, I've always had some of the best maths teachers actually from primary school. I remember in primary school, I had people like Mr. J.K. Godo, a Ghanaian. I had Mr. Sagbo. Before then, I had one Mr. Shegun Unga who, attended St. Finbar's College and then came blazing with mathematics. So always had excellent maths teachers. So from there, I went to Badagry Grammar School. I had people like Mrs. Padonu Obaba, Mrs. Padonu, right, and Mr. Amorua, Mr. Oyerin, the very excellent guys. So by the time I was leaving BGS, that's Badagry Grammar School. My best subjects were mathematics, physics, technical drawing, and French language. Interestingly, and of course, if I told you these were the subjects I liked, you would naturally tell me to go and study engineering, right? Thankfully, I wrote JAMB 5 times. I took direct entry from one time, making 6 attempts at JAMB. And in the process, I kept getting scores and that probably were below the cutoff, which I felt that was actually not the direct case because by the time I finally got admitted into FUTA, I got admitted because of post UTME, because all the while UTME was a mess, so to speak. But when I had the opportunity to finally show myself, to show that what I could give, that was when I got admitted into FUTA after the fifth trial. I have 1 minute to go. So somehow I got into a diploma in marine engineering at Federal College of Fisheries and Marine Technology, Victoria Island, Lagos. And I was the best in class, but I wasn't enjoying myself. I didn't enjoy all the practicals, going to the workshop and filing metal. Some people like that. It's not my thing. That was where I finally discovered, oh, okay, this engineering. Thank God I didn't even study a bachelor's level. thank God it was diploma, and I could now finally find my path into FUTA. And one of the best decisions I've ever made was to study mathematics. So I'm a mathematician by choice, proudly so. And the beautiful thing is that as a mathematician, as I speak, I collaborate with all kinds of people. I'm currently collaborating with a police. Okay, should I be saying this? I'm collaborating with police people in all over the place. I have 2 police papers we're working on right now, talking about scheduling policing and things like that. I'm collaborating with a philosopher right now, a professor of philosophy, psychology, sorry, in the US. I'm collaborating with a civil engineer in Papua New Guinea. And apart from that, these epidemics and everything. So I mean, so the fact that with my maths I can, it's like math is like a unifier. It has a place in everything. Math is just the language of existence, basically, and as a result of that, all of that can keep going. So how did I get here? I went to FUTA, got a first class, went for service in Katsina State, got retained in FUTA, taught in FUTA, all the while. By the way, I didn't want to do my bachelor's degree in Nigeria. I didn't want to do so, but I had to end up doing that. So one advice I can get from that is, while you're pursuing what you want, don't be stagnant. Keep moving. Because at the end of the day, I ended up getting a PhD position in Japan because of my master's in FUTA. Let me stop here so that my daddy Gio can talk.
All right, sir. Thank you so much. Thank you so much, sir. So, the academy is so amazing to have you here. Like the 2 of you, basically. I know you're asking like, how do I like put the 2 of you together? So I've been following the 2 of you for some time.
You just
I've
bring
seen
twin
their
brothers.
amazing
Come,
work
it's
in
okay. That's fine.
like. So I just say like, yeah, there are not 2 other people that can do this better than the 2 of you. So thank you so much. So Dr. Adeniji, the same question to you, sir. How do we get here? What is the journey like? You also get to be a mathematician by choice or by chance?
All right. Thank you very much, Latif. Can you hear me very well, right?
Yes, I can.
Okay, yeah, great. Thank you very much, Latif. My apologies. It's almost my bedtime, so I'm a bit sleepy. No, not a problem. But I was telling Dr. Danso that I've been watching for a while, and as for me, I always like when people put their head above the waters. Those kind of people, I connect to them. Yeah, because there are so many legal things that will put you down into the water. But if one way or the other you can find your head above the waters, and as soon as I saw your message, I was like, no matter what it will take, I have to say yes to you. Wow. Yeah, I'm very busy, but when I saw your message, it took me time to respond. I was like, hey, I have to do this because this is one of the champs that is coming up and giving voice of mathematics to the entire world. I really appreciate what you do. I sincerely really do. Okay, my case is very different. I'm very funny. I never liked mathematics. Yeah, I hate it with passion, to be honest. Yeah, because I told the teacher, like, you see, you're just asking for X. I pass it to get promoted at the level of C. Well, you come today, and you know, mathematics teachers of those days, they pride in that thing, eh? Just because you have one out of many that is learning it, so their shoulders are very high. And so for that, I just didn't like it. But because I don't want to repeat the class, so I just have to pass. But it's something I never liked at all. But there was a change somewhere. So I met this big brother. You have big brothers on the street. And then I was in SS1. And I said, see, his name is Sheye. I used to call him Bro Sheye. I said, can you teach me indices? He laughed. He said, I know where you're coming from. Then he taught that thing. And I was like, this thing no hard now. That was how I said it to him. Then that very particular day, I went to the lesson and the master teacher was not around. I love to transfer knowledge. I love to teach what I know. Then I told the manager, I said, see, can I take the class? I don't have to get paid. Then I went to the class and I said, see, guys, I just learned this thing. And there are guys in class who were very good at mathematics. So I said, there might be mistakes, but see, let's just learn together. And that was where it started. That little thing. So it wasn't just the math itself, but it was just the ability to transfer what I know and understood that very particular day. So fast forward to that time. I never see it as something I wanted to study. I was just passing. So I did computer engineering. Then I wanted to study computer science because I also went to Polytechnic of Ibadan. I just didn't stay for long there. So on getting there, I noticed that then computer science was in vogue. And I noticed that everybody wants to study computer science. 250 of them in class, 200 in class. But boy, if all of us are plenty like this, how we go know now? So, fortunately or unfortunately, I see every circumstances as God working out something. At UNAD, my application form was missing, and I was asked to come and refill the application form again. Hi. So I asked myself, what will I fill? First choice, mathematics. Second choice, mathematics. Third choice, mathematics. And then mathematics department are very few. So I got it. Then 200 level, I wanted to leave that department. Then I met somebody called Professor Kwame Enoch. He came to class and mentioned something about an advert in South Africa and what it does with complex analysis. Out of 20 students, 15 of us have decided that we are leaving down to physics department. But when we finished that class that day, we stood up and gave him a clap. Like, so somebody can just talk about math like this with advertisement of, I think it was Gouda or Heineken. So that changed the whole narrative. And that was where my desire for mathematics came into being. And let me round up by saying this. I didn't finish with the first class. And I didn't finish with a 2-1.
Wow.
I finished with a 2-2. Yeah. So I'm one of those I'm one of those guys who believe that no matter what you finish with, you have what it takes to shake the table. You have the voice to speak at places where those who finish with the first class and the 2-1 can speak, and those who are with a brilliant mind. And that is what has helped me till today. So is it by chance? I don't know. Is it by choice? Maybe as a way of escape. But that's where I am, and that's where I am now.
Wow, this is so fantastic. I really love the story, and I love the fact that we're actually coming from different angles, so it actually make it easier for our audience because at least even if you cannot see yourself in one person's story, you will see it in another person's story. And this is for you that you are currently struggling with. You are for some reason your grade is low and you're feeling like, oh, there's nothing for me again. So you have seen an example of someone that graduated with 2-2 and is on a global stage, like doing so well in mathematics. If he's not saying it to himself, nobody will believe it. If you not say it with his mouth now, nobody will say, that. So that is it for you. That's when you have results, it cancel whatever thing that other people can consider to be a limitation. I'm just going to go right into the question now. So I'll be taking Dr. Dancer first. So the first question is, so what makes a mathematics degree? As you know, we're having a global panel session with Dr. Adunji is joining from Australia, Dr. Dancy is joining from Japan. So what makes a mathematics degree from Africa particularly attractive to international scholarship board? So we have a lot of mathematics students right now, they're finishing and they want to go abroad to have their masters, to even have their PhD. So what makes a mathematics degree from Africa here attractive to scholarship board over there? Like, what's that advantage that we have, or how should we tell our story? What should we? What is that thing that we need to focus on when we are applying for the scholarship, sir?
Interestingly, math is one of those subjects that that are kind of maybe not quite, but it's a kind of math is somehow democratized because Pythagoras theorem is Pythagoras theorem anywhere in the world. Maybe the little differences we can have is maybe how is the math taught and who is teaching. For me, I mean, for my observation, I feel that the biggest problem of mathematics and the biggest cause of math phobia and math trauma is the teachers. We've not had good teachers to pass the message around. And that is why I do what I do. That's why I have a YouTube channel where I take sword, for instance, and I start from what is sword and I go gradually and build it up to Olympiad level. Because I just don't want to take a question randomly and solve. Now, so I think the only disadvantage you may have as Nigerians, which can be easily made up for, is this, that most of the times we solve mathematics to get answers. But when you come to Japan, when you go to Australia, when you go to America, so after getting the answer, the question is, so what? So what does your answer mean? I remember I put that, then if you can solve and get the answer, hey, that's all. But then I got it, I was humbled. Like after solving and I was excited, my professor would be like, so can you explain? Wow. So I now discovered, oh, the approach to teaching maths has to be different. Like things like we need to emphasize, like when I say an exponential equation, how many people can imagine it? Can you imagine an exponential equation in your head? Like, okay, I say logarithmic equation. So it was this experience that pushed me back to now go and have that approach. So you want to have a picture like, okay, because at the end of the day, all this logarithm and everything, they're actually models, right? For instance, you see something like logs always saturate somehow. You see inverse tan always saturates. And when you are modeling like chemical reactions that reaches the point and saturates, you want to do that. So, well, so first of all, I think there's that little thing that maths is one of those areas where you can easily make up, because that was why I had to leave engineering, because I'm like, I was mostly, if I had studied engineering, probably I would have still got a first class, but I think it's easier to make up in maths than to make up in engineering. Of course, we also have people from Nigeria and at MIT and Harvard now. So the thing is, when you get out here, you get a bit of shock first, but but no break. Yakubu manage. After if you can pull through 1 or 2 semesters, you'll be fine. So I think that the biggest advice I will now give is a math degree is attractive anywhere in the world, no matter where you studied it, especially if you can prove yourself. So the advice would be, whatever it is, even if you attend Omolu Urugbo University and you studied maths, if you can get a first class, get it. Of course, you already know that whether you get a first class or not, it doesn't matter. There are other things you can still do. But if you can get a first class, get it, right? So because that's your first leverage. So after that, if you can have a good mentor, for instance, I like to tell the story of what's this guy's name? He's now in University of Indiana. He was best graduate student from your school. You should know him.
Yes.
Sunday, Godogbe. Yeah,
Godogbe.
Godogbe. Yeah. So Godogbe has a mentor in that school. I've not seen him. I don't know so much about him, but he's your mentor too, right?
Yes. That's our HOD.
Excellent. Good. Having someone like that, because I see they publish some work even in mathematical biology. And then, so for someone like you having Professor Bakari as mentor, you don't know what blessing you have. So graduate to a good degree if you can, then have a mentor. And maybe Dr. Jimmy will also chip in here how with Tutu, how he was able to navigate and find. Of course, you already mentioned Dr. Enoch Okpayemi. I mean, if you know Dr. Enoch Akpayemi, I've not met him before. I've not met him before, but you know, he made a lot of wave one time trying to. He was talking about Zeta and something. It became a very global stuff. Like, of course, it was controversial and all that, but that means somebody was doing something, whatever it was, you know, that was making that people could relate with. So, so a maths degree, you can easily. I mean, many things I teach on my YouTube channel, I was never taught. So, but in the process of teaching, I learned. So, I think one big advantage is if you can easily learn very fast. As a mathematician, if you do well, you can learn very fast. You can be fine. You can become comfortable anywhere you go. At first, it will be shaky, but you'll be fine at last.
All right, sir. Thank you so much. So I hope you are catching it. I'll be first class if you can do that. Especially those that are currently in school, 100 level, 200 level. Don't do it as much as you can. Try all your best, and then have a mentor. Very, very important. Then learn very fast. All right, so I'm just going to go to the next question now to Dr. Adejimi, which is how can a student currently studying pure theoretical mathematics pivot into a remote career in data science or AI without losing their mathematical mind? Because the aim of this panel session is that we're not just talking about just global opportunity. We say global opportunity, we're not just talking about scholarship, we're also talking about remote careers. How can you, as a mathematician, we know you can work from anywhere, work in various fields. So how can someone that study, I know for some universities now, if you study mathematics from university, what you learn most is pure mathematics. They are capital of pure mathematics, and there are some universities they focus more on applied. But both of us, those that study pure and you study math, is still most likely theoretical. We are still like trying to get the answers, not really the so what that Dr. Dansu is talking about. So how do we like go from there to position ourselves for remote careers and transitioning to remote careers in data science, AI, and other fields?
Right. Thank you very much. I would say this. Being born in this era or growing in this area is a blessing because there is no limitation. That's just a simple truth. As a mathematician, you have to be very curious. Technically, one of the things that pushes me away from pure maths then to applied was because my brain is wired in such a way that I need to be able to translate something that I can into something I can see or something I can touch. If I can't touch it and I can explain it, then I don't have a say in the society. It's just here. The essence of whatever we are doing is what Professor Bakari said during his keynote speech, his speech rather. You just have to find a way to let your mathematics speak volume in the society. That is when it can be appreciated. So whether you study pure math, irrespective of what you study, the first thing is this: can you actually see what you're studying? That's one. Number two, can you actually have a view of that thing solving a particular problem in the society? Let me just paint this. So today, they know I and Dr. Dansu as Japa, Japa model, Japa this, Japa that. So I and Dr. Dansu are like twin. We talk a lot. And it's been on my mind. So one day, we were talking. And we're talking about this Japa thing. It wasn't even invoked then. And I said, Dr. Dansu, this thing has been on my mind. Can we model it? And I said something about Dr. Dansu. And that is why I say you need to surround yourself with people who see that anything is possible. They can start it though, and in the middle and find out that there is no way out. Even in that no way out, something else will come up. Dr. Dansu said, yes, it's possible. And that was how we started. Yes, it took like a couple of years because of, life happens, but we did it. And that was just because my brain is wired in such a way. How can I translate this mathematics into something that is meaningful to the society? So if you want to move from pure science into data science, into machine learning, into deep learning, into AI, the question is this: I already have a residual knowledge. With the knowledge I'm about to acquire, of what benefit is it to the society? When you come to the Western world, there is something that is always at the back of their mind. How does this inform policy making? There is a project I'm doing at the moment. Dr. Danso is part of that project. That project is presently speaking to a certain thing that is in vogue in Australia as we speak. It's a project that we took the data of 30 years. By the time I was done with it this afternoon, it was about 70 pages. And that thing is speaking to what is happening in Australia. And how did we cluster the entire thing? Part of that work has to do with machine learning. Part of it has to do with spatial analysis. Part of it has to do with policy making. And part of it has to do with the compartmental models. Hardly will you find that kind of work in a paper. And what led to it? How can we cluster an entire information into one box that it will speak to parliament, it will speak to governmental organization, it will even speak to the academic sector? So if you're coming into data science, you already have a residual knowledge. The question is this: what would this knowledge do? How will it affect the society? I will round up by saying this. They always say one thing. I landed in South Africa. Other countries I've been to are here in Australia. If you're going to start a project, the first thing is this: as a policymaker, can you fund this work you are doing? If you yourself can answer that question, then forget it. If your answer is no, then forget what you're doing. If your answer is yes, then that yes will tell you, okay, what tool do I need? Okay, I need to analyze data. Then I need the knowledge of what data science. 2, beyond data science, I need to also forecast. I need to understand data patterns in this thing. Then, which means I need to understand machine learning algorithms. The quest and the thirst will change your taste bud and your diet in the quest for that knowledge. Once you have that, you'll be blazing all through.
Wow, wow. This is so amazing. This is so amazing. Thank you so much. Thank you so much. I really see that. See, the thing is that when you listen to people like Dr. Adejimi and Dr. Ademiji and Dr. Danso, you can see the depth of knowledge that they have. You can see that these are people that have gone beyond looking for S and getting S to people who have answered the question, so what? So you can see that it's coming up every time that just like the theme of the summit, it's beyond the numbers, it's beyond whatever you have been taught or whatever you have learned. It's about how is this thing making an impact? How is this thing making a difference? What's this thing saying to the world? And how is it making a difference? So quickly, because of our time, just going to move to the next question, Dr. Dan. So in your experience, so what are the top three industries globally? Dr. Dan,
Yeah, that froze right
Yes.
there. Yeah. There was a little bit
Okay, do you
of
get the
gap. I didn't
question,
hear
sir?
what you were saying.
Yeah. Okay, so the question is, in your experience, what are the top three industries globally that are currently starving for mathematical talent?
Yeah, I mean, of course, we know these days, technology drives everything. Now look at everything that has changed the history of the world. It's all about technology. At first, it was just the discovery of fire that you can hit two stones and you get fire. Technology. From there, we had, I mean, maybe in no particular order, you had, so the fact that the printing press, there was something it led to that you can preserve knowledge in books. It led to something. Then, of course, when you talk about core technology, then you talk about the idea of computing, Charles Babbage and Ada Lovelace, and then from there, the internet. So you have the invention of computer, the internet, and now AI. Now all of these are driven by mathematics. Charles Babbage, Ada Lovelace, mathematicians. Then you come to internet. So who are the people surrounding the whole idea of internet? Mathematics and physics most of the times, and now AI, right? So if I just say tech or maybe more specifically AI, I feel every mathematician now, interestingly, up to my PhD level, my maths was more of the classical a system of ODE, equilibrium points, this one and that one, excellent stuff. So because of my maths background, I entered into the whole data science sphere. In fact, I have an accumulation of, if you are a total novice in data science, I have a set of playlists on my channel where, I mean, the first one is, if you don't know anything about data at all, start with Microsoft Excel. Everybody should know that I have 45 videos on that. From that, I went on to basics of Python basics, 60 videos. Then from there I went to data analysis with Python, 35 videos. Then from there I went to SQL with Python, that's database management, 11 videos. And finally machine learning, covering supervised learning, unsupervised learning, and reinforcement learning, 60 videos. So for anybody who is totally a novice, because at the end of the day, AI is all about data. AI is about data, and the 5 core areas of AI, I mean, if you ask me, machine learning, which is my niche, by the way, machine learning, natural language processing, machine learning, natural language processing, computer vision, expert systems, and of course, robotics. So I feel that instead of mentioning particular industries, go where the world is going, AI. So if you can find a niche in AI, then you have cybersecurity. For me, I've chosen machine learning. I've chosen the data part of things because I really like to make sense of things that don't make sense, actually. So I'll just summarize my answer in AI. Yeah.
All right, sir. Thank you so much for that. Thank you so much for that. So, my people, AI is the way, AI is the goal, and there are multiple sub-industry, like sub-field in AI that you can focus on, and then you can also like explore other fields. So, just very quickly, so Dr. Adejimi, sir, as the founder of the Black in Mathematics Association (BMA), how has professional networking specifically accelerated your career across three continents?
All right. Let me say this before I answer that. So sometimes, there are certain people you move with. Whatever they turn into or whatever they've transformed into will not take you by surprise. Okay, so I'll give an example. So Dr. Aminat, I was telling Dr. Dansu, of course she doesn't know I was here. We did masters together at Unilag.
Wow. Wow.
Yeah. And whatever she's doing now, there is a track record that this is where she is. See, if you don't have a track
Perfect.
record, you can't just wake up suddenly. I'm using Dr. Aminat as an example. 2, I respect Professor Emmanuel Bakari for one thing. He's one man that I know that went against the tides of the wind. And that's what an ego does. So I see him as an ego. So he's one person I know who actually changed the narrative of what I call wealth creation. What I mean, wait, not the money now, but deposit of people bringing what is in the Western space into Nigeria. As far as I'm concerned, have not seen it. He is one man. So, which means that he didn't go and just left. He brought the wealth and established it here in Africa, here in Nigeria, Yekiti. So, what I'm trying to say, I always said those two things to answer your question is that if you cannot draw strength from where you are going in times of when you are tired, they are not going anywhere. Let me say that again. If you cannot draw strength from where you are going in times of when you are tired, when you are depressed, when you are lonely, it looks as if nothing is working. They are not going anywhere. Because if where you are going is really meaningful, then it's worth dying for. So what has helped me in getting across all of these places and networking, there is a desire in my heart. And that desire is we need to change the narrative of what mathematics is in Africa. We are brilliant, we are exceptional. When things are not working in a system that does not make sense, the Bible says that can anything good come out of Nazareth? We, as Nigerians, we came strong out of it. Sorry, forgive me for quoting the scripture, but that's something I can bring out, and that's just it. So we are tough. So there is nowhere we are a student. So the desire to change the narrative of what mathematics is beyond the numbers is what actually started BME. Because I sat down, we need how do we bridge the gap with the old generation, the present generation, and the generation to come? And that's where Black in Mathematics started from. Of course, Dr. Dansui he's part of the founding member. Dr. Kayode, I called them one day, I said, can we do this? And as a result of that, yes, by that position, it keeps me on my feet in order to keep connections and relationship everywhere so that let me use the word, if my guys, my people, if they need the exposure, I have one professor who says he's in need of a postdoc. I can say, okay, Dr. This, please, you can submit there. Why? Because I want everybody around me to grow. I know that we have what it takes to excel where we are going. So this has actually helped me to build a whole lot of network. And as a mathematician, that is something we need to understand. See, it's one thing to be brilliant, it's another thing to be smart. Now, it's one thing to be brilliant and smart, it's another thing to understand how emotional intelligence works, how to manage relationships, because you are not there for yourself. You are there for the people who are coming behind you. So these are the thoughts, the principles that actually helped me in having a whole large network. And lastly, I'm a problem creator, and I know how to gather people to solve the problem. As a mathematician, you must know how to. Dr. Modbademu, I think Professor Modbademu now is in University of Lagos, is one of my mentors. He will tell me sometimes 12 a.m. I'm still at his office while we were doing masters. He will say, Denji, in this world, you have to create problems. If problems is not running after you, then run after the problem. Those were the things that helped me. So you must understand your qualities. Do you create problem? Yes. Then how can you solve the problem? Do you have those who have the tools who can solve the problem? Yes. But you don't have what it takes to solve the problem, but you can create it. Gather them around. leadership. So that's why you can see someone like Professor Emmanuel Bakari. I call him an evangelist of mathematics that we have in Nigeria. He goes from places to places, educating people, changing. See, it's because he has a dream. So beyond the numbers and beyond the first class and the 2-2 and the third class, character-wise, passion, selflessness, these are things that happens, and these are things that has helped me to build a whole large of network. And to be honest, I've not gotten there yet. I'm extremely expanding that network as much as I can, and that's it.
Wow, wow, thank you so much. Thank you so much. I personally I can testify to Professor Bakari because if not for him, I'll not be here. My own like trajectory changes when I first get to meet him in August 2024 in a conference. And that's what's like, bro, I cannot be anywhere else. Like I have to be in the camera. So I have to find all means to be here. So thank you so much for that. And you must also note, everyone that is watching here, that you have always been shouting, become a problem solver, be a problem solver. So it's not enough to be a problem solver again. You have to be a problem creator. Then also know how to gather people to solve that problem. So don't just be a problem solver, be a problem creator. So I have just two more questions now, but then I will actually want the two of you to say something to the questions. The question is, and I know that especially this particular question is one that can take us hours to answer, but I just want us to like respond to it as short as possible. So the question is, you have both surmounted significant challenges to reach your current heights. What was the biggest cultural or academic ordeal you faced when moving abroad, and how did you solve it? So, Dr. Adeniji, you would like to go first on that?
Let Dr. Nancy go.
Okay.
Go now. You know, yeah, like I called him Daddy Gio, and you can already see the signs. So that we won't waste their time. Let me go. All right. Now the so for me, I think the biggest hurdle I've ever had to overcome is rejection. So when I count the applications I've made and all the rejections, well, I give it a conservative estimate of 500, like writing professors, you know, doing all that, like writing professors, writing, I wrote GRE, I wrote TOEFL, writing all of those things, writing most will not answer you, you know. In interest, at some point, I even got 5 admissions. I got admitted to University of Technology Malaysia, no funding. I was supposed to get funding from my university, then I couldn't get it. Then I got admitted to University of Loughborough in the UK, no funding. I got admitted to the University of Porto and Coimbra in Portugal. I was number 11. They were going to give funding to 1 to 10. So I got admitted to Memorial University in Newfoundland in Canada with some partial funding. You know this funding that they will give you if you calculate the balance. If they pay 99% safe, if you calculate the balance, you know say you know fit. So then finally I got admitted to Washington State University, but no funding still. But then I just knew I had to keep going. I almost got admitted to University of Saskatchewan because I was like the closest, very, very close. I was number 4 on the list, and I think they had funding for just 1 or 2 people. So rejection. So there was one time I was in church in Akure, and you know there was this guy. It was the time of MMM, so there was this guy in our church, and he had written JAMB 2 times, and he was tired of writing, so he wanted to take MMM as a career or things like that. And my pastor just called me like, hey, Emmanuel Ababo boy, sorry, like how many times did you write JAMB? Then I think I was a graduate assistant or lecturer in FUTA or something. So and I was like, I wrote JAMB 5 times. I took the 1 time, making 6 altogether, and that gave him energy. He wrote JAMB again, got admitted into Oye Ekiti, studied business administration. Now he's a big boy in Lagos. So I think resilience, like if you are beaten down, get up again and keep going. Like sometimes you need to lie down, sleep first, or sometimes chop first, then wake up later and continue. Like never, and somebody said if you fall down, pick something up, pick a lesson. That why did I fall down the last time? So because one thing I know is I know many people like that. If you don't give up, something will surely give at the end of the day. If you don't give up, the world self will stand up, say, guy, oh yeah, come and go. You don't try. So,
Don't
but
you?
the problem is most times we give up too early. I think that's the thing. So the biggest problem I have had to confront, like I told you, I didn't want to do bachelor's degree in Nigeria. From secondary school, I was writing SAT. I was preparing for SAT. I was preparing for TOEFL. But when I saw the money, $24 down in 2000 and maybe 2001 or 1999, like $24 for SAT, $110 for TOEFL, mean that even my going to Nigerian university itself, my parents could not afford it, you know. So when I saw the money, I just calmed down. And that was why I said the other time that while you're looking for what you're looking for, make sure you're making progress where you are at. Because at the end of, I could have just sat down like, oh, if I don't go abroad, nothing. I've been trying to go abroad since secondary school. So I did diploma, no abroad. I finished bachelor's degree in FUTA, no abroad. I had to go on with, in fact, I enrolled for PhD in FUTA. You know, I had enrolled for PhD in FUTA before I finally now got, admitted to Japan. Like 22, I got enrolled in PhD 2 years, 2015 in FUTA. Though I wasn't serious about it because I felt I just wanted to leave, but I just had to keep it going, right? So finally, the thing came in, the MEC scholarship came in, and I was like, life. I mean, since I got MEC scholarship, I've not recovered from it. My wife finished the third class. We were classmates in maths. She finished third class. Now she's an assistant professor in this same university here right now.
Wow.
Third class mathematics. Then, I mean, it's like, so we give up too early because by the time you're able to break through that, so you've been getting all rejection, but one yes will change all the story and it will be something different. So rejection, if you don't give something, we surely give. When you fall down, pick something up. Never give up. Easy.
Wow. Thank you so much. Thank you so much. So, Dr. Adini, do you like to say something to that? Like, wow.
Like that's why I said everything. But let me just add this Maggie to it.
Okay.
To be honest, one of the things that pained me was like, I wouldn't say pained me a bit, life happens in the university. I don't know if it's the same now because there's a lot of, knowledge and things. Yeah, I finished with a 2-2. So I asked myself, if the tire of a car, out of four tires, if one is missing, then the car cannot work. But if the tire is deflated, there is every possibility that car can get to a certain destination where it can find help. What I'm saying is this: keep moving. If you don't move, who will help? That's just it. Keep moving. So I told myself, I said, me that finished with a 2-2 at UNAD, when I got to UNAD, when I did the master's exam for the University of Lagos, I was on the merit list. That was where I met Dr. Julius. I looked very small when I met Dr. Julius Ehige, who arranges NAC. And then I was with NYC. He's like, small boy, what are you doing here? So I came to write the master's exam. See, what you are will reflect the people that will help you, will reflect the people that will surround you, and you have what you need to. That day, when I saw Dr. Julius, he looked very young to me. He looked like somebody I'm supposed to become. And that was how I kept that relationship to today. Yes, today I have a PhD, but when I see him, I'll say, Dr. Julius, how you be? How you do? You understand what I'm saying? So it's there. I've had rejection is a normal nomenclature, but what do you do with the rejection? When you see the rejection, what do you say? We move. Because if you stop applying, then there is no expectation to get any result.
Exactly.
And I will say this: you can be brilliant though, but if you don't have character, you're going nowhere. Because that your same character will make you look at the results and you will give up. 2, sometimes when it's not working, go and eat your food, watch Netflix, sleep, play around, gist, then come back to it. When Elijah ran away, they gave him food to eat. Food was the problem. They said, oh boy, eat, because the war that is coming ahead is heavy. What I'm trying to say is that rejection is normal. You have to keep hitting that hard. That a hammer and a nail, tornado nail. As much as that nail, there is nothing it cannot penetrate. There are some wall that thing cannot penetrate. But a carpenter knows that when he picks up the hammer and keep hitting the same spot, he listens. This is where wisdom comes in. He listens. Once there is a space, a vacuum in that, he puts the nail and he hits it. You must understand ethics. You must understand knowledge. You have to be wise. Rejection is normal. When you receive that rejection, give thanks to God and move on to the next thing. Because the same you who give thanks to God when the rejection came will be the same you who will give thanks to God when the testimony comes. So it's not going to catch you by surprise. It's just going to become normal to you. And do not see scholarship or moving abroad as Dr. Nancy, please help me here. The end to the means or the means to the end? Which one?
Like, the end to the means, yes. The end to the means. So when you get it, there are more things that should follow. Just like you talked about Professor Bakari, going abroad and then bringing.
Exactly.
So you can be abroad and you're still doing things back home.
Yeah, you get what I'm saying. So now it's once you do this thing, you need a knowledge, right? When you get there, the same way these people have moved ahead is also the same way you will speed up. And I'll round up by saying this. When I knew that I had a tutu and I got to Unilag, I had to step up the game. I was sleeping. There's a place called, I've forgotten the name. It looks like a bunker. The mosquito there knows no respect. It does not understand mosquito net. But I told myself, if this is the price I have to pay in order for me to gain ascendancy, I will pay the price. We were sleeping inside that place. Because when the mosquito bites you, you can't sleep. You will wake up. You will tell yourself, Alpha, measure Lebec and integration. How do I understand this thing? Because everything has to work for your good. So please, don't be ashamed about rejection. Where I finished with a 2-2. Dr. Danso's wife finished with a third class. We are here. Are we proud to talk about it? Yes, because we paid the price. Because what a 2-2 means or a third class means is that you need more work to do so that you can speak where the first class are. Dr. Danso, no verse. So, Latif, no verse. You guys are in the same WhatsApp group. Yeah.
Just me na first class low I take finish. Latif na first class upper.
But you understand, that is it. Yeah. So if you can finish with the first class, please do. If you can't, maybe life happens and you can't. Just know that, ask yourself, what do I need to fill up the space? It's either you enjoy it now and work hard later, or you work hard now and enjoy later. It depends on how you look at it. So whatever you have, the rejection is normal, but how you handle the rejection is all left to you. Well, we are still handling the rejection up to today because rejection is every day. We applied for a grant. We won about 30,000 Australian dollars. I say, after there was a rejection of another grant. We say, okay, God, we thank you. We move. Everybody you see on LinkedIn, they all have a story to tell. Don't be moved by the today I'm happy, I'm glad. Oh boy, before that I'm happy and glad. That was pain. Yeah. So just enjoy your reading. Be happy. This life is too short for you to be always hungry and feel negative. Time will tell and time will work things out for you. Rejection is part of the journey. If it's very smooth for you, man, maybe you're in a subset D that I don't know about. But if the road has rocks, then we can, we relate. We think.
Yeah, wow, thank you so much. Thanks so much. I'm supposed to have one last question, but I will not ask because I believe the question has been answered already. Question is supposed to be you are going back to your final year, like what is that thing that you're going to do differently, knowing what you know now. But I think what I will just do now is let me just take our last word. So I know we have said a lot of things, and this And I'm sure that if you are here and you have not
I
gotten
think that
anything.
question deserves an answer, really. I think it deserves an answer.
Oh,
Yeah.
okay. So let's just read the question in full. So if you could go back to your final year in a Nigerian university, what is the one thing you will do differently to prepare for the global stage?
So very simple answers. Now, if I were to go back, I would be active on Twitter, X, and LinkedIn. I was there. Like, I mean, I got on LinkedIn maybe around 2009 and all that. Then I got on LinkedIn, no, X, Twitter, 2013, but I wasn't using it for anything serious. But when I went for a Society for Mathematical Biology conference in Sydney, Australia, sadly Dr. Jimmy was not there then. So maybe that we've not. By the way, I've not seen him before. We've not met before, face to
Wow.
face.
Yeah,
Yes.
we've not met before.
Yes. So I mean, maybe that would have been my opportunity to see him, but very soon I know something is going to happen again. So
Yes, sir.
yeah, I was in Sydney, went for SMB conference, and people got award for retweeting the conference on Twitter, and I'm like, Miss FD Twitter now, what was I
Wow.
doing? And that was when I also discovered that all the years I was looking for scholarship, the people were looking for me on Twitter, and I wasn't there. So the people you are looking for, they are on LinkedIn, they are on Twitter, looking for you, but you are not there, maybe because you are not a social media person. You know, these days, if we Google your name and you don't appear, you don't exist. That's what it means. Let me just stop there.
Wow, thank you so much. I think everybody can catch it, including myself. I have a friend I always say like, I'm like, see why I don't Twitter. I feel like Twitter is just too this for me, but I don't have any option. I have to
Wait,
come
now there's Leke.
Twitter.
Now there's Leke. It's a more homebred thing from the owner of Arise News. So I mean, do you know one thing I did
Wow.
in Twitter till tomorrow? I follow more people than I have followers. But on Leke, you know, I'm trying to push the first mover advantage.
Following.
Now I want to become the
Wow.
mathematician of Leke. Right now, for the first time, I have more followers than I have people I'm following. So it means there's people are saying something. So you don't want to sleep on it. Leke, Leke. It has.
Wow.
Get on that right.
That's great. Hey, thank you so much, sir. That's so amazing. Dr. Adejimi, back to you, sir.
Yeah, if there's something
I'm really stressing you, sir. I'm so sorry.
No problem. Well, this is part of the price we pay. Yeah. If there's something I'm gonna do different back then, to be honest, this is gonna sound very funny, to be honest, is that there are some people in my set, Dr. Danso is going to laugh, that deep down they need a push, because if we have them in this field, to be honest, they'll be more than me. I know what I'm saying. As in, they are more explicit, sound than I am. That's one thing I would do. Because imagine we have folks like Professor Bakari and these other few guys who are, you see, they are not making the name outside there. They are making the name where it is impossible to make the name. Imagine we have many of them a ripple effect. The face of what we know in terms of mathematics would have changed in Nigeria. And remember, if Nigeria leads, every other African nation leads.
Exactly.
That's just it. Maybe it's not the kind of answer you're expecting, but I don't know. But that's something I will have done different. Yeah, because then many dreams were killed. Yeah, many dreams were killed. Many saw mathematics as, if you study it, it's a failure. Then secondly, what I would have done different is that I would have tried to understand many things. You see these things that we cram, a lot of la cram la pop. I would have, because then there was internet, but we didn't have access to the internet. Yes, we paid the price, but imagine some of these things that you guys know now. You guys would be on the jet space flying. So because the little I knew then was what I was teaching my friends. But if we had access to those things, we would have done more. We're very grateful to God where we are now, because those dreams, God helped us to lead into it. But the truth of the matter is those are the two things I will have done different, because we have great minds in our nation. You are one of them coming up. I've met a few upcoming ones, and I so much encourage them that forget the fame, forget the name known, effect the change. That change that you have done will spark everything. Thank you. I hope with these few words of mine, I've been able to convince and not confuse you.
Yeah, thank you so much. Thank you so much. As uncommon as it is, actually, I really say that this is something that we all need to learn. Like I have some of the same experience when I was in school. So you see a lot of people. These people are brilliant. In fact, when I talk to people, I tell them I'm not actually the most brilliant student in my department. People will not be this, but because you are the BGS, that's what everybody is going to see. But you see people who are actually very hardworking, and I think it also relates with what we're doing with Excel in Mad Africa, because we know that as mathematicians, we don't really tell our story enough. I'm very sure there's some people like today now, their life cannot ever remain the same again, because they have had things, they have just exposed, they have seen things that they don't even know is
Dr.
possible,
Nasu,
and now their
Latif said,
mind.
he's not the most brilliant person in his department. Really, 4.9 what?
I can relate with what he's saying actually.
I know.
Because my set, people taught me things, but they didn't even have they didn't even have a 2-1. I can imagine what he's saying.
Yeah.
I can relate actually. Yeah.
Thank you, sir. So a lot of people that actually believe, but then there's always that element of luck, I would put it that way, and that element of, I don't know, also elements of a lot of things put together. But then the most important thing is that we are here, and then we can make sure that we also give back. Can also give back. So thank you so much, sir. I don't know, my Daniel is raising his hands, and I don't know. Dr. Dan is supposed to be in a meeting. I've heard him down for 48
Yeah,
minutes.
I got wisdom, and I was able to delegate someone to take over the meeting because I feel I'll be more needed here. So we are good.
Wow. Wow. Thank you so much. So Daniel, please go ahead with your question. Yeah.
Okay,
Please go ahead.
Good afternoon, sir.
I can hear you. Okay, yeah.
Okay, can you hear me now, sir?
Yes.
Okay, good afternoon, sir. Good afternoon, Mr. Emmanuel and Mr. Adejimi.
Thank you so much.
Hello. You want us to like like Dr. Dansu and Dr. Adejimi?
Okay,
it's not a problem. For me, I don't think it's a problem. I think I don't care about the title.
Not a problem
it's
at all.
good, but for me, it's like not a problem. Please go ahead.
Okay, sir. Okay, let me introduce myself. I'm Daniel Akiyemi. I'm currently a final year student of Taisho and Federal University of Education, and I'm in my second semester. So I'm currently working my project on the early onset colorectal cancer. But straight to my question, I just have two major questions I want to ask. And because you're already out of the country, and let's be factual with ourselves, let's be ourselves. We Nigerian students are looking for every means to live out of this country. Most of the time, want to do our masters there, want to do our PhD there. So my first question I would love to ask is, since you have gone there before, you say you go before us and make every crooked way straight. So at least since you have gone before us and you have passed through those crooked ways. So I like if you can recommend, sir, possible universities. You know that when you were doing your application, there are some university you know that I wouldn't have wasted my time even applying for this university. So I would like to know if you can maybe recommend some, or the importance of that. I know that, okay, yes, these are some universities that if you can apply for them, you are good, you have all your motivational letters and everything, you are good to go with it. And my second question, sir, is, are you open to mentorship, sir? So that's the two questions I have to answer.
Dr. Dansu, sorry, can I answer that first question?
Please answer everything, sir.
Let me be very frank with you, Daniel. You see, deep down your heart, if the motivation is wrong, you won't get it. That's just it. The question is, why do you want to do a master's? If you're going to do a master's to Japa, forget, you will tell, because you're not going to fund yourself. It's expensive. Then if you're looking for scholarship, then it's not something that is in a hurry. You have to write, you have to apply. It's a lot of work. So the question is this: it's not about the universities. See, all those universities, scholarship is not free. Oh. Just let me clear you. How do I say that in pidgin English? Make I clear you. I mean, there is no free money because they are paying you to do the job. So the question is this: is that why do you want to do it? If that answer is not pure, forget it. Time will frustrate you. That's the simple truth. Time will do what? Will frustrate you. So maybe if time has frustrated you, then you have learned your lesson in a way, and your heart is and motivation is correct, then you would, except if you have your money. If you have your money, even having money to pay for school fees is different thing. The migration on its own is expensive. So I just need to chip in that there is that it's not about there is no university that is easy if it has to come to do with research, because it is fully funded. It's not automatic. So what you're supposed to be asking is, what do I have that is worthy of investment? If you have $1 billion now, Daniel, and you want to give scholarship, I'm sure you'll be giving scholarship to best of brains. So ask yourself, if I'm going to fund it, can I invest in myself? If yes, then start the journey. If no, then sit down and ask yourself, what can I do? So the second question, I don't know if I've answered your question, but I'm just drawing your attention back to the source. Then the second question, Dr. Danso can answer.
I mean, I want to still talk about the first question. Actually, I mean, from statistics, right? Especially from a FUTA perspective, and of course that can work for Nigeria too. There are some schools that I've noticed that they have a high chance of taking Nigerians, Futarians as case study. So I know in the US you have places like Georgia State University, Kent State University, BGSU. What's BGSU again? Bowling Green State University. There is Florida State University. There are different schools like that. Then if you're into PhD financial services, University of Delaware. Yeah, I mean there are schools like that actually. For mentoring, of course, that's what we actively do. We have BMA is a kind of mentoring platform. Then I have a WhatsApp group called Opportunities with EJD. In fact, if you check the playlist on my channel, you see a folder for Opportunities with EJD. It talks about different scholarships, different countries that we have been through. So we have a WhatsApp community where we share ideas. Interestingly, one of our community members is coming to my university here by she already got her visa. She's coming by April 4th or something. So like that's part of the efforts we've been putting into mentoring. So we mentor people, we do all that for sure. Yeah.
Right, thank you so much. These people will not allow us to go. Another person is raising his hand now. So I don't know. So we just want this up by 2 o'clock. This is like 2 o'clock West African time. These people, like our doctors, they're supposed to be in bed right now, and then they are here. So but then what I'll just say before I call the last person is that whatever you are giving, I was talking with my guys. That is actually one of the people that supported this program a lot to make this happen. And I was talking with them yesterday night. So I'm finishing, but I told them that whatever they have been given to give. So whatever we have been invested in right now, we're invested in you right now. We are doing it so that you can also go out there to invest in other people. Okay, so Patrick Clement, please unmute yourself and ask your question. So that'll be the last question for the day, and then we're going to write it up.
Good day, sir. Good day, Dr. Dijimi and Dr. Emmanuel. I'm a 300 level student of mathematics. Thank you, sir. I'm a 300 level student of mathematics department, University of Uyo, Akwa Ibom State, Nigeria. And actually, what I basically learned is pure math, analysis, OD, PD, and so on and so forth. Actually, I want to pursue a career in financial mathematics, where I can venture into quantitative analysis and so on. But a roadmap, is there like, in brief, can either Dr. Emmanuel or Dr. Dejimi like have any knowledge or a brief pattern, a brief way I can just, from my field of study, I can liaise with another or any other field that can actually push me towards that my objective, that my goal of being a quantitative analyst?
I cede the floor to my Daddy Gio.
Okay, I'm just going to say something very few about that. I think I know one or two people who are experts in that field. To be honest, they're really blessed because communication this time around is very interesting. It's easy. So now that you know that that is what you want to do, it has to go through the financial lines. I think so. On your bucket list, let me use the word bucket list. On your bucket list, one of the things you have to ask yourself is, number one, what tools do I need? What knowledge do I need to acquire? Then, if I have to pursue that route, how do I translate the knowledge I would be acquiring on this journey into something that is industry wise? For example, you would hear that Professor Bakary is consulting with what's the name of that guy who did the sub on her? Wale, am I right?
Yeah, Dr. Ido.
Okay, Dr. Ido, right? The guy on her, isn't it?
Okay, today, yeah, Mr. Ido.
Yeah, Mr. Ido. So you can see he's doing his PhD, and yet one of the problems they are solving is with the malaria center in Abuja. They are getting the problem. So what you have to be doing, to be thinking on your third bucket list is this, is that the third one, this financial math or these financial procedures, how can it solve an industry project? Meaning that go online, search for industry projects or problems that has to do with financial mathematics. Am I right?
Yes, sir. Okay,
Patrick?
sir. Yes, sir. Yes,
Am I
I'm
right?
listening. Yes, sir.
Yeah, exactly. So there is a doctor in Federal University, no, in okay, I know it, EXU, Ekiti State University, Dr. Sunday Faduba. Anything that has to do with numerical schemes, financial math, he's an expert in that. He does that. Or just go online. See, the thing is this, you have to be very proactive. This is your life, and you have to pursue it with every energy that is on your inside. It's awesome that at 300 level second semester, first semester, you know what you want to do. Years ago, people don't know. They just go in this direction. So, like on Twitter, on LinkedIn, there's this lady on LinkedIn who her field is in financial math. Her name is Dr. Tolulope Fadina. I've interviewed her before in Black in Math. So you understand what I'm saying? She's on LinkedIn. Read up their papers. Look at how they are picking some of these things to solve industry projects or problem. That in itself will open up itself to you. You will begin to gain confidence, some degree of knowledge about where you are going, how you want to go about it, and how you want to do it. By the time you are done and you want to write a cold email to a professor, you will not lack words to put in that cold email. You understand? Because already there is a wealth of knowledge, wealth of ideas that is actually, in fact, the problem you would have is you will be confused about which of the problem you want to solve. Why? Because you have amassed a wealth of ideas and knowledge. In that case, you will begin to understand how your partial differential equation is needful in that area. You begin to understand how your ordinary differential equation is needful in that area. If you now want to crown it up with cream and chocolate, then now ask yourself, how would data science or machine learning, well, I wouldn't want to say deep learning because deep learning needs a lot of data, but how would machine learning come to play in that knowledge? One of the secrets you must understand is what I call interdisciplinary knowledge, research. If you look at me online, my research is in two places: epidemiology and social modeling. Social modeling like migration, unemployment, JAPA, bullying, and things like that, because I like to use mathematics in that area. Then epidemiology like vector-borne disease, tuberculosis, and things like that. So as at that time, you will begin to have the foresight of where your field would go. Then you would add machine learning to it, you would add AI to it. All you need to do is do a lot of internet research. By that, it will really help you and open your eyes. And say, do not be scared to write anybody about what you want from them. If you see that person and you see that this person has what you need, right? See, I will say this, Latif, I'm so sorry. There's some kind of email that when I see those email, I don't even open it. Email like keskose@gmail.com. I will not open that email. But if your name is Patrick Clement, let it be patrickclement@gmail.com, because every other person you see up there, they are careful to even read some things. So the content of what you need is what will speak on their acceptability of you and their validation of you. I hope that makes sense. I don't know. All right. Thank you.
So thank you so much. Thank you so much. Since Dr. Danso is out of here a bit, so we're just going to call it a day now. I want to really, really appreciate you, sir. Thank you so much for all you have invested to be here. Like Dr. Adejimi have been here since the first minute of this session. Thank you so much. Include with Dr. Danso is even like he has been he has a lot of programs. So like join the other programs, come back here, ask to even delegate someone else to be part of another program that is coming up. And that is it. So we really appreciate you, sir, as we don't take this for granted. Thank you so much for all you've done. And so all our participants, we also want to thank you for being here. You have invested your time, your data, everything. And we really hope that this has not been a waste of time for you, that this has achieved the aim, that you have been able to see that mathematics is actually beyond the numbers. That it's not just enough to find X and find Y, that you must now start thinking of how do you solve problems, but even bigger than that, how do you also create problem? So thank you so much, sir. Thank you, Dr. Dijimi. I will send you a message on LinkedIn. Thank you so much. Like I know how much you sacrificed to be here. Thank you so much, sir. God bless you, sir. And thank you so much, Dr. Dansu. Moderator, are you there? Thank you, sir. Bye, sir. Thank you so much, sir.
Yeah.
Thank you, sir.
Bye.
Yes, sir. Please let's appreciate them, please. I can't see your thank you in the chat. Say, hey, thank you.
Thank you.
Thank you very
Please
much.
unmute and say thank you. Everybody
Bye.
unmute and say thank you. Unmute.
Thank you very much, sir. I really appreciate it.
Thank you,
Thank you,
sir.
everyone. Bye.
Thank you. Bye. Have a great time.
Yeah.
All
Love you
right,
all.
sir. Thank you so much.
Thank you.
Yes,
Thank
sir.
you.
Yes. Wow. So we can round it off.
So thank you so much, everyone, for joining. Thank you to our amazing convener. Thank you for organizing such an amazing program. We all had a great time. To our speakers who took out time to join us here today, we deeply appreciate you. And to you, amazing participants, definitely, if we plan a program and you choose to not show up, things will not have worked out. Thank you so much for staying true till now. We deeply appreciate your commitment. Thank you so much. And thanks for engaging too for the wonderful questions. Thank you so much. And once again, happy International Day of Mathematics.
Right. Thank you so much, Temiloluwa. Yes. Thank you so much, Amy, for that fantastic moderation. Thank you so much. Everybody has been here. I've thank you again. I will thank you again. Thank you so much. So the next thing now is that after all of this, what is next? What are we doing next? So you're part of a vibrant and growing community of mathematicians across Africa, and we're also going to, in fact, even have globally. So make sure you stay in the group. We have more programs in store for you. This is just the beginning, it's just a starting point. If you are not registered for this program and you just saw the link somewhere, someone sent you the link, make sure you registered. So there's actually certificates of attendance for everybody that participates in this. So while we might not be able to track that year, because some people have gone, joined network and all of this, and we even have people that are on YouTube. Excuse me, for our YouTube people, so sorry. I did not even sort of check in. We might have missed some questions there. We are so sorry about that. So what I'm just going to say is that make sure you're registered, make sure you join the WhatsApp group because that's where you get all the information. The replay is going to be accessible on YouTube. You can go back and go and watch it. And I strongly suggest you do that. I personally will go and watch the replay myself again. All right. So a form will be sent, and this is why you need to register and join the group. A form will be sent to the group to capture everybody that participates in this session. Those people, it's only people that fill the form that are going to get the certificate. But then let me just tell you this. If you did not join, for those that will just see the form and just feel like, oh, let me just for me to put my name, you are going to ask you specific things that you learn from all the sessions. So make sure that if you miss any part of this session, you go and watch it. If you see your response and we say that we did not see anything satisfactory, that shows that you are really part of this summit, you not get your certificate. Okay, so I want to appreciate you once again. Thank you so much. And more importantly, please, I want you to take screenshots of everything you've learned from here. Go on your Instagram, your Facebook, your LinkedIn, your Twitter, tag us, post about this, tag me, tag the speakers, tag all the speakers, tag everybody. Let them know that you learned something here. Please mute yourself, Mr. Patrick. Okay, so make sure that you post this, let them know that you are part of this. See, when you post about this, you're not just doing us a favor by getting more people to know about what you're doing, is that you're also positioning yourself, okay, that, oh, you are someone that is open to knowledge, you're someone who always invests in him or herself. So from there, too, people can say, yeah, this person is attending this conference, that means you know something. So post on your social media, tell them what you learn, tag me, tag all the speakers, tag the moderator, tag Tim Lua, tag Daniel, tag everybody. Daniel has been the one disturbing you on the group, posting about the link, all of us. So I just want to use this moment also to appreciate everybody that makes the success. As of yesterday, as at to 11 yesterday, we are still on the call. As at to 11 yesterday, we are still on the call discussing how this thing is going to go. You see, anything that is working, if anything has gone well today, it is not just me. In fact, what have I done? Daniel has been awake since Daniel slept when I've been awake. Like I've been posting on the group, engaging everybody. Timolo has been there, doing a thing. Surprise has been there. You watch any video, Surprise has been there. You watch our marvelous, yeah, marvelous spoken word. That's someone that did that. Okay, Esther has been there. Joshua has been there. A lot of people. Oh, Daniel from Twitter has been posting, mentioning a whole lot of presidents have been part of this from day one, sharing to their community. In fact, if you're here, you most likely find the link somewhere. It is someone that posted that link. In fact, go to that person and go and say thank you. Thank you for posting the link to this because I've learned and gained a lot of things. Okay, so we want to appreciate you, everybody that, and there are people that we don't even know that have shared about this, that have called people, that have invited people, and we don't even know you, but we still want to appreciate you. Thank you so much for everything you've done. Thank you so much for making this a success. This is just the first, and I'm so happy that I believe that this is a success, yes. And so I almost forget. So our national president, Mr. Yusuf Soni, thank you so much for your contributions. I don't take it for granted. We really appreciate it. This is our first collaboration, and we hope that we still have more collaboration to go. So thank you so much, everybody. This is we're going to call it a day. So if you can, please, I would like everybody to please on their video. Please on your video. Let's take a a shot together. Okay? Please on your video, on your video, on your video. Yeah, turn on your video. Daniel on your video. Temilolo on your video. Please everybody show on their video. Miss Abby, Faith, Esther Lawode, Adetola, Bukola. Yes, my boss. Uh Mr. Uluwafemi Awubajo. Wow, good to see you here. My boss. How's everything? Yeah. Gwena Large Doctors. Let's on our video. Let's on our video. let's make a screenshot. Please wait till I'm not doing it that yet. Okay. Yeah. Yeah. Okay. I can see our announcing by national president. I can see Dorcas. I can see Gojubola. Okay. I can see Daniel. Wow, Daniel is on the beach. Wow, that's good. I can see a lot from Obajo. Okay. All right. Let me just take that. We have more people. Yeah. More people is showing now. Thank you all for joining. Thank you. The replay will be available. Make sure you go through it again. Thank you so much. I know you have taken your time. Over 4 hours. Like this is 4 hours. Wow. Thank you so much, everybody. Thank you. And have a fantastic day ahead. Bye, everyone. Yes.
All right, sir. Thank you very much.
Thank you. Timmy, you are muted.
Thank you very much, sir.
Sorry, goodbye, everyone.
Something.
For staying true till now.